Group Executive at CSIR responsible for the NCPC and other hosted programs. Dr. Sandile Malenga, responsible for smart societies here at the CSIR. Tami, I don't know if Tami's in the room yet, but in absentia, Tami Klaasen, Director of Regional Industrial Development at DTIC. Mr. Bongani Mamela, Executive Manager responsible for hosted programs. Ndivo Rapulu, Director of the NCPC, and our leader here. And then representatives from UNIDO at home here in Pretoria, as well as from Vienna. Welcome back. You're not used to this weather, I'm sure, from us. And then representatives of every industrial park, every industrial area, every industrial zone, and members of the tenant community at those. We particularly welcome you, because this is who this conference is for. Welcome. Thank you for setting the time aside. Welcome to those online. I hope you will stay with us for the duration. And remember, we have somebody online who will be taking your questions and trying to respond to any glitches. We have our safety briefing now from the CSIR ICC.
Thank you, Program Director. Morning, ladies and gentlemen. Welcome to the CSIR ICC. My name is Jobe Mkachwa. I'm the Safety and Setup Coordinator. In case of an emergency, please do not panic, do not run. We'll have a fire alarm that will sound. Please use the nearest exits. Our emergency team will escort you to the assembly area. As you step out of reception, you turn left. There's an assembly area, but do not worry, our emergency team will assist. In case you're not feeling well, we have medics on site to assist you. Please use hand sanitizing stations all around. When you step out, you'll see the signs to the operation facilities. As you turn left towards the foyer, we have the operation facilities. Please take care of your personal belongings, as this is a public building. Please note when you go out of the gate, security might ask you to switch on and off your vehicles to verify ownership of the vehicles due to Gasfontein being a hotspot for Toyota vehicles. Please enjoy the rest of your session. Thank you.
Okay, before I introduce our first speaker, which is the Director of the NCPC, I'm just going to ask a housekeeping request. Could those of you on the ends, could you just, for this session, could you just move in so that those who are arriving a little bit late are able to get in without climbing over you? I've noticed now that we've got to the point where every single row, and it's fine, I'm not forcing you, I'm just asking. I'm getting a vehement response from some of the areas. I'm just making the request that if you can, if you just move in a few seats. This session ends in about an hour and a half's time, where we'll go for tea, and then we're going to split into groups so it won't be so full. I really appreciate that. And then if I could remind people to put your cell phones on silent, that would also be greatly appreciated. While you're doing that, let me introduce the next speaker. Ndivo Rapulu is he was the director of the NCPC. NCPCs around the world were established by United Nations through UNIDO, and each one has what they call a director. It's not the same as what we call a director here, but he leads the NCPC South Africa and has done for the last 15 years. Ndivo will be here to just introduce you to the NCPC if you don't know who we are, and share a few of the highlights that we've experienced over those last 15 years. Ndivo?
Good morning, everyone. I was told last week in another gathering that all protocol observe, it's not protocol. So I don't know how then to say all protocol observed. But I'm recognizing my seniors and everyone. I've recently been given glasses by the doctor. So I see everyone senior is wearing glasses, so let me also prove that I'm joining the club. But thank you for being here physically, because there's an option for you to be here virtually as well. And we are looking forward to the inputs that should come to improve where we are with our program. And thanks to the funders, I wanted to share with you the last 10 years of what we have been doing in the industrial parks. At the moment, I think I'm pressing backward. Okay, it's not me pressing, it's someone there. At the moment, for the last 10 years both GEIP, the Global Eco-Industrial Park Project, and CSID, we have gained a few knowledge and information that we want to share. Our mandate remains that we are a program that uses resource-efficient and cleaner production methodologies and tools to facilitate the economic transition to a green economy, low carbon and climate resilient economy. We are funded by the DTIC. We mobilize funding for implementation of projects that we do, and for that reason, the Swiss embassy is represented here, and all our other partners and the technical parties that participate in the program. Okay, should I stop pressing? Okay, all right. Feels like I'm going backward. Sorry. When you come from the far north of the country, you must realize technology, when it gets there, everyone else already passed. So we have 6 areas of support that we provide to industry. These areas are supported at no cost or at very low cost, because they are part of what we call grant funding by the Department of Trade and Industry. So for every industry, for every company or industrial space, we do what you call assessment of the plant, and this is to do gap analysis, to determine, and benchmarking, to determine what needs to be done to improve the performance of the area. And we also do skills and capacity building, and we support then the implementation of the recommendations from the assessment studies that were done. And we also help in developing bankable business proposals in case then you're required to go to a financial institution to ask for funding support. We also then use this information for 2 purposes. One, advice with policy, government with policy that is required to facilitate the transition, or to advise industry on how to become competitive and efficient with resource management issues. I want to share with you some highlights from the last 10 years, but practically 2015 to 2025. We worked with 1,200 companies, and these highlights are what we benefited or what we got out of the companies. 131 of the 1,200 companies, we measured energy consumption and energy management, and we implemented tools or methodologies that reduces their energy dependency, and we came up with a 3 or 4 million in rand value of the savings, and this could even be seen from a practical bill that they receive from the municipality, the reduction, but it was also in terms of their plant's ability to perform even under energy scarcity. In terms of water, we realize about 7.4 million savings, and waste. So we measure energy consumption, water consumption, and waste management issues of the company in an area. All this comes to a total of about 3.1 billion rand over the last 10 years. Now, this is cumulative numbers, because in the next 10 years, if these companies continue to maintain and operate using the tools that we have provided, the amount goes up every year based on what they do to implement the change. An average saving in a company comes to about 2.5 million rand cumulatively to that 3 billion. We also looked at 85% of the savings were energy, of course, with load shedding, with energy reduction, what's the other word they use to mean load shedding? It becomes the biggest benefit for us to look at energy issues, but it's also because the country has gone into a path for independent power producers to introduce renewables and alternatives. And industry is beginning to adopt off-grid supply mechanisms, and the parks themselves are also initiating programs that helps industry access renewable energy. So 85% it's energy, 9% is water. Amazingly, the biggest challenge we are experiencing as South Africa, because we are a dry country, it's water management issues. So energy is because of the cost drivers, the amount of money an individual company pays to have the lights on. With water, it's still cheap, it's still accessible. Most often, we do not record and look at underground water or alternative sources of water. So when we talk water, most often we are talking about tap water or water that's supplied through the grid, the network. 6% is waste. Now, with the promulgation of the extended producer responsibility, I have a perception, a feeling that the waste part, because of the cost that would be incurred if you continue to dispose your waste and not find alternative use, then that 6% might go up as well. But also the difficulties in accessing technology that reduces waste with regard specifically to issues of decarbonization, compliance to CBAM. We are now very aware and conscious of the European CBAM standards, but the UK is coming, Japan is coming, Canada is coming, Australia is coming. So at some stage, majority of what we call the G8 or the group of 20 will have the same policy framework as the EU on carbon, and it will drive your water, your energy, and waste issues up. And this slide would change, definitely change. So in all these companies that we worked with, we calculated that after 10 years, we have reduced the national carbon footprint by 9.2 million tons of carbon. And we calculated this, so energy at 80% becomes the biggest contributor. The second contributor for this, it's the basic cost of carbon. For example, I don't know if you are ever interested in understanding, you moving from your house to here this morning, how much carbon you have created and you have generated or you contributed. And we're looking at when a product sits, a bottle of water you're going to drink, from the maker of the bottle, from the refinery or to the purification plant, and also all the transportation required, the storage, the process that was engaged and involved in the process of getting your bottle of water in this room, then we are looking at the amount of carbon that is affected by that. This gives us an opportunity to say South Africa has low-hanging, easy target ways of facilitating CBAM compliance as an example, or decarbonization of the South African economy, just transition of the industry of South Africa. One of the key outputs is that you can't do all this using the same knowledge and information. You need to augment it. You need to find ways to support it. And that's one of the key reasons we sit in the CSIR, to look at what are the research and innovation that we could benefit from. But also we're looking at what are the South African academic and educational requirements for us to facilitate the transition. We have in the past, when we started this program, all the technical expertise in the NCPC came from either Europe or North America or Asian countries like Japan. At the moment, we have worked with those experts that were brought when we have developed about 9,600 technical experts in South Africa. And funny enough, or interestingly, we are now exporting them as a commodity from South Africa to Asia. At the moment, we have a few who are in Asia, to the rest of the continent. We have a few who are between North Africa and West Africa. I think there's someone also in East Africa. And these are experts in a number of training programs that we have developed. So you could either become an energy management expert, and under it there are energy systems optimization specialists that we have developed. All of them, 7 of these courses or training modules are NQF, National Qualifications Framework, accredited or registered. It means you could either get credits through your key CTO process, or for if you are an engineer or a scientist and you need CPDP points, you could get that. Or you could go to some of the universities that we have partnered with at the moment, and you could get an NQF level 7 qualification from those institutions. We are working also with the TVET colleges to also get the lower level of qualifications. These courses are available either directly through NCPC, and this is where the low cost comes in. An average expert level training, which takes 12 months, will require you to have, in NCPC terms, about 12,000 Rand. But if you go to UJ, you will get that for about 25,000. You can go to CPTUT, and you could get that training as well. We're working with, I'm aware, Free State, we're working with Limpopo, we're working with Technikon Tshwane University of Technology and Valley University of Technology. So soon you could have most of the universities offering this, so we don't have to offer that. Thank you so much. I thought I should share that and welcome you. And hopefully we are going to find lessons and knowledge that will help us support how we move forward with the program. And all the best. Thank you.
Thanks, Ndubo. So last week we were in Cape Town to support some side events at the G20 discussions in the Environmental and Sustainability Working Group. And there was a gentleman there who was one of the very first experts who trained. I think he did the initial training back in sort of 2012, 2013. He subsequently did a number of other expert level training courses. And he said to me, came to me and he said, I just got back from, he went to 2 places. He went to Singapore, and I think he went to Korea. I said, that's cool. He said, no, I got back because I've been training, oh no, it was Sri Lanka and Korea. He said, I've been training people. UNIDO is actually contracting me to go. He says, the places I've seen, the places I've been because of the Industrial Energy Efficiency Project of the NCPC and UNIDO. He says, the NCPC and UNIDO have been such a blessing to me. And that really made me sort of appreciate my job and appreciate the impact that we've made. And it's not just him. There's a number of experts who are traveling the world training. So that was a personal story, not just the numbers that are on the screen. I'd like to introduce the Group Executive for Business Excellence and Integration here at the CSIR, who's going to welcome our guests on behalf of the CSIR, Dr. Kaven Naidu.
Thank you, Program Director. Good morning, everyone. I hope you're all well. It's a bit nippy this morning, but hopefully the warm welcome you'll receive here today will make up for that. I think we are missing the presence of the Deputy Minister, but he was called for an urgent meeting with the President. But in his place, we will be relying on the DTIC colleagues for leading the morning's proceedings. So good morning to all of you and welcome once again to Department officials, the Chief Director Gerrit, Chief Director Mr. Matefane, who from Special Economic Zones, and a Special Advisor at the DTIC, who's essentially standing in for the Deputy Minister this morning. Our various partners, UNIDO, Daniel from the Swiss Embassy, Head of Cooperation, officials from the DTIC and other departments, entities of state, esteemed industry leaders, ladies and gentlemen, it really gives me great pleasure and honor to welcome you this morning to this conference on sustainable industrial spaces. It is quite a fitting setting for this event and quite timeless. As you know, the NCPC has been hosted by the CSIR, and CSIR turned 80 years old 2 weeks ago. Just want to tell you a little bit of a story about the CSIR, and I think it's the right time for it to get you warmed up for the rest of the program. So I think this introduction to the CSIR maybe frames the morning's conversation quite nicely. If we go back in time a bit, 80 years to be exact, just prior World War II, South Africa's industrial base was largely dominated by agriculture and mining. So it was resource intensive, but focused on production and processing of raw materials. It's a little known fact that during the war, South Africa manufactured millions of spare parts and did repairs for ships, aircraft, instruments, land vehicles. We manufactured clothing, blankets, boots, and canned food for the global effort in the war. What the country saw was this value of this industrial base and the role of science and technology in this strategy. Other countries also saw this and they were speeding ahead, and so the CSIR was created to catapult South Africa into the 20th century, to enable existing industries and to give rise to new ones. Over the years, it built institutions in physics, chemistry, buildings research, timber, telecommunications, wool, road construction, food and nutrition, mechanical and electrical engineering, and many, many more. It spun out various institutions that you might recognize today, but you didn't know came from the CSIR. For example, the National Metrology Institution was part of the CSIR and spun out from the CSIR. The NRF, which hosts the Square Kilometre Array, which is the largest science project on the planet today in terms of space science. The South African National Space Agency, which tracks all satellite and space vehicle traffic in our bit of sky. The Medical Research Council, the Human Sciences and Research Council, even the South African Bureau of Standards was once housed by the CSIR. It's quite an incredible achievement that the CSIR has become the mothership for all the entities that are important to the South African ecosystem. Did you know that we were the first team to track Sputnik in 1957? The lithium-ion battery that you find in your cell phones today, the material was invented by Michael Thackeray and his team at the CSIR in the 1990s. We built the world's largest 3D metal printer, the Aeroswift. At the same time, this laser technology is being used to refurbish Eskom steam turbines in situ rather than scrapping and buying new steam turbines. During COVID, we developed and rolled out 18,000 ventilators. And in the last 5 years, we supported close to 800 SMMEs, localized more than 100 technologies. We licensed more than 55 technologies to industry, executed more than 700 projects for the state, and more than 300 new technologies. We have 9 clusters in the fields of health, chemicals, advanced agriculture and food, mining, manufacturing, defense and security, water, energy, built environment, climate change, digital transformation, and mobility. In addition, we host several hosted programs on behalf of our partners and stakeholders. The National Cleaner Production Centre is one of them, and this conference is being hosted by them together with their partners. Other programs include the Technology Localization Implementation Unit, the National Earth Observation and Space Secretariat, which hosts the National Space Conference, Circular Innovation South Africa, Innovation Bridge, the Regional Innovation Support Program, Aerospace Industry Support Initiative, the National Foundry Technology Network, the National High Performance Computing Center, and all the high-speed links for the universities and the square kilometer arrays managed by us. I've been here for more than 27 years, and you will excuse me, colleagues, if I'm a bit biased, but I don't think there's another organization like this in the country and on the continent. So we now look to the tasks that lie ahead. So despite the advances, the country and the continent face huge challenges: persistent poverty, unemployment, infrastructure deficits, resource insecurity that constrain inclusive growth. And Africa's abundant natural resources have not really created the system of equality, security, and peace for all that we envisaged. They have not supported this level of infrastructure development and resource security that are needed for communities to thrive. These vulnerabilities are compounded by intensifying environmental risks, now ranked as the most significant global threat to business over the coming decade. South Africa's prolonged energy demands, recurring droughts, and mounting global competition for critical minerals exemplify the nexus of climate, resource, and development risks. If we are to attain the objectives of the National Development Plan, or at least the intentions of the development plan, the AU Agenda 2063 and the SDGs, we must place development at the center of everything that we do. Policy, funding, technology development. But it can't be solved by one forum, by one conference, by one sector, by one country. It's a collective effort, we understand that. But it would require collaboration on a scale that we haven't seen before. So my colleagues at the DTIC, our partners, you know, my aunt was a fortune teller, and a bit of that might have rubbed off on me. I think we will be engaging further, not just over the next 2 days, but how we can join forces to collaborate more, and to how to transform our industrial spaces more. The DTIC is a key department of government charged with the very important task of leading trade and industry, and we believe this partnership with the CSIR as the engine for research and technology development can really catapult us into the next decade. Thank you for all of your presence here today. Thank you for your support, and we really hope that you have a productive 2 days. Thank you very much.
Thank you, Dr. Naidu. So, Kaven, I hope that in 20 years' time, when somebody stands up and tells the stories of the mothership when it's 100 years old, NCPC will be one of those that you mention alongside the Space Agency and the NRF. We can hope, we can see into the future, apparently, and we hope that becomes a reality so that sustainable industry can be a reality. As mentioned by Dr. Naidu, we had apologies from the Deputy Minister, and so I'd like to both introduce and thank Mr. Mautu Molefani, who is the Chief Director responsible for SEZs and IDZs, and apologies if I'm getting his exact title wrong, so we will allow him to introduce himself properly. But thank you, sir, for stepping in at the last minute. We truly appreciate it. And if you would come and give the keynote address, we'd be honored.
Thanks, Program Director. Indeed, the title, I could just say that I receive. I'm not a chief director. My name, colleagues, is Maodo Molefani, Program Director, got it right. I'm the Special Advisor in the DTIC. I previously served as a Chief Director. I'm also a Board Chairperson of the Tshwane Automotive SCZ, which is hosted by the CSIR. Our offices are here. I'm also linked to IDC as a Technical Advisor on Special Economic Zone. Indeed, our Deputy Minister has sent his apology, and we said that this is a very important event, Deputy Minister. We'll make sure that the DTIC is well represented as the duty calls at the presidency. So, Program Director, distinguished guests, colleagues from industry, in particular, the colleagues from research institutes, colleagues from CSIR, National Cleaner Production, UNITO, Jeff, and many other industries. Colleagues from the DTIC, I see Mr. Fore is here from Green Industries. I see Mr. Klassen is also here, a very multi-talented gentleman who is a regional development specialist. But many of you don't know that he's also a singer. He's a theologian. He's also a permanent program director in the DTIC. When he wants to, he can also preach for you. It is both an honor and privilege to address you today as we gather to reflect on one of the most transformative instruments available to us in building a competitive, inclusive, and sustainable economy, our industrial parks. Industrial parks have long served as engine for regional economic development. They have anchored manufacturing, attracted investment, provided our much-needed jobs to thousands of South Africans that are employed today. Yet today, our economy faces profound global shifts driven by technological challenges, climate imperatives, evolving trade dynamics. Industrial parks must evolve beyond their traditional roles, ladies and gentlemen. They must become platforms for innovation, incubation hubs for small enterprises, and center for beneficiation of our, and value addition for of our minerals. If we truly transform our industrial landscape, industrial parks must be reimagined as smart, sustainable ecosystem and spaces where science, technology, and production come together to drive inclusive growth. Program Director, industrialization has always been a backbone of our modern economies. It drives exports, strengthens supply chains, creates a kind of decent, sustainable jobs, and our citizens needed most. In South Africa, the revitalization of industrial parks is therefore not just an economic priority. Rather, it is a developmental imperative through the Industrial Park Revitalization Program and the Global Eco-Industrial Parks Program, implemented in partnership with the United Industrial Development Organization, Swiss State Secretariat for Economic Affairs, and our National Cleaner Production Centre. We have begun to transforming these spaces into global competitive, environmentally sustainable, and socially inclusive industrial ecosystem. Our success is really being recognized globally. The East London Industrial Development Zone was named by UNIDO as the leading eco-industrial park in the world in 2024. That recognition was just not symbolic. It affirmed that South Africa industrial policy, when underpinned by sound partnerships and visionary planning, can compete at a global level. But the true measure of our success will come when every industrial park and special economic zone across the length and breadth of our country embodies the same standard, combining industrial competitiveness, innovation capacity, and environmental stewardship. Distinguished guests, to build resilient industrial base, we must empower micro, small, medium enterprises to true lifeblood of our economy. Industrial parks provide the ideal environment for SMMEs to thrive, offering access to shared infrastructure, markets, and technical support that they could not otherwise receive. In this context, we are envisioning industrial parks as incubation hubs, spaces where new enterprises are nurtured from concept to commercialization. By embedding business incubation centers within our parks, we create entry point for youth-led and women-owned enterprises to participate meaningfully into the mainstream economy. These hubs provide mentorship, access to finance, technical assistance, and linkages with anchor industries. The clustering effect within industrial parks ensure that startups are not isolated, but instead part of an interactive, innovative ecosystem, learning, adapting, and benefiting from proximity to larger and more established industrial players. In addition, industrial parks model introduce a unique advantage, industrial symbiosis, where one company's waste becomes another company's resource or opportunity. This collaboration not only improves environmental performance, but also creates new market opportunities for smaller firms specializing in recycling, energy efficiency, and material recovery. The result is a circular economy in action, one that creates decent jobs, reduces waste, and generates shared values. Program Director, South Africa's mineral and agricultural wealth has for too long left our shores in raw form, only to return as finished goods at many times the value. Industrial parks offer us a most practical means to reverse this pattern through beneficiation and value addition. By clustering processing facilities within our industrial parks, we can integrate value chains from extracting, smelting, refining to component manufacturing and final product assembly, all within one coordinated industrial ecosystem. This will not only increase export, but also anchor local supply chains, stimulate technology transfer, and diversify our regional economies. For example, industrial parks linked to mining regions can host metal fabrication clusters, producing components for automotive, rail, and renewable energy industries. Agricultural processing parks can convert raw produce into processed foods, textile, and bio-based materials. Beneficiation within these parks is not merely an industrial activity, it is a strategic shift from price takers into global commodity markets to becoming value creators in sophisticated production networks. And to support this shift, we must harness the power of science, technology, and research, which brings me to one of our most important national assets, which is CSIR. The Council for Scientific and Industrial Research stands at the heart of our ambition to build knowledge-driven industrial economy. As a leading science and technology institution in the country, CSIR plays a pivotal role in advancing research, developing new technologies, and bridging the gap between discovery and deployment. The CSIR's capability in advancing manufacturing, digital technologies, material science, and renewable energy are directly relevant to the modernization of our industrial parks. Imagine an industrial park where CSIR-led innovation labs operate side by side with manufacturing plants, developing prototype, testing industrial processes, and training the next generation of engineers and technicians. By embedding CSIR facilities and innovation nodes within our industrial parks, we can ensure that every investment in infrastructure is also an investment in knowledge and capability. These partnerships can help industries adopt cleaner production methods, improve the energy efficiencies, and integrate digital technologies such as artificial intelligence and automation, making our industry smarter and greener and more productive. Furthermore, CSIR's expertise in circular economy design, waste valorization, and environmental monitoring supports our national commitment to sustainability. It ensures that our growth is not achieved at the expense of the environmental, but rather through stewardship and innovation. Such collaboration between CSIR, government, and industry embodies the triple helix model of innovation that has propelled many successful industrial economies. It aligns research, enterprise, and policy in pursuit of shared national goals. Industrial transformation, ladies and gentlemen, cannot succeed without human capability. Our parks must therefore serve not only as space for production, but also as centers of learning. We are working to ensure that vocational training centers, artisan colleges, and technical institutes are integrated into industrial parks ecosystems across the country. This alignment between industrial policy and skill development is crucial for addressing both youth employment and evolving demands of modern manufacturing. Through partnership with entities such as National Cleaner Production and CSIR, we are implementing training programs in resource efficiency, cleaner production, renewable energy systems, and advanced manufacturing processes. These initiatives are equipping South Africans with green and digital skills required for the future of work. Skills development also supports inclusivity. When young people, women, and historically marginalized communities are provided with training and enterprise opportunities within the industrial parks, this benefits industrialization beyond just factories into homes, towns, and local economies. Ladies and gentlemen, no industry strategy can ignore the twin imperatives of environmental sustainability and climate resilience. South Africa remains one of the most water-stressed nations in the world. Climate-related disasters such as the devastating KwaZulu-Natal floods, which disrupted major industrial operations, remind us of urgency to build resilient and resource-efficient industrial spaces. The eco-industrial park model directly addresses these challenges. It promotes water recycling, renewable energy adoption, waste minimization, and energy efficiency. Companies within eco-industrial parks collaborate to manage shared resources sustainability, reducing both costs and environmental risks. This is not only good for the planet, it makes business sense. Globally, investors and buyers are prioritizing environmental, social, and governance criteria. By adopting sustainable industrial practices, our industrial parks position South Africa as a preferred destination for green investment, capable of meeting the highest standard demand by international markets and trade regimes, including the carbon border adjustment mechanism in the European Union. Thus, sustainability is no longer a moral choice, but it is an economic necessity and competitive advantage. The transformation of industrial parks into smart, sustainable, and inclusive spaces require whole-of-society efforts. No single department, agency, or sector can achieve this alone. We need coordinated governance, clear alignment between the DTIC, provincial governments, and development finance institutions, and stronger partnership with the private sector, academia, and international partners. Through GIPP Phase 2, supported by SECO, and implemented by UNIDO and GIZ, we are expanding this model to more industrial parks and special economic zones. These partnerships bring not only funding, but also global expertise and technical support provided by these partners. We call upon private sector to continue embracing sustainability as a business opportunity, investing in green technologies, supporting supply development, and integrating SMMEs into their value chains. We call upon research institutions such as CSIR, our universities to deepen collaboration within industry, ensuring that innovation is not confined into laboratories but translated into products, processes, and employment. And we call upon communities to actively engage in the planning and governance of these industrial parks, ensuring that local development is inclusive and responsive to the needs of our people. When these partnerships align, the results are transformative. We have already seen this in SEZ such as East London, Gucha, Richards Bay, where industrial parks have become innovative employment and environmental centers of excellence. Now we must take this success to the next level. As we chart the course of South Africa's industrial future, one truth is clear: industrial parks are no longer just clusters of factories. They are engines of new kind of development. They are spaces where ideas become industries, where research meets production, where communities find opportunities. They are spaces that must integrate innovation, beneficiation, skills, and sustainability into a fabric of our economic growth model. By transforming our industrial parks into incubation hubs, centers of beneficiation, and collaborative innovation systems, we can build industries that are globally competitive, environmentally responsible, and socially inclusive. The CSIR and our National Research Network are key partners to this vision. Together, we can ensure that science and technology become the foundation of South Africa's reindustrialization, enabling us to not only to catch up, but to lead in the industries of the future. Let us therefore be bold. Let us scale up our networks, replicate our success, and continue building the institutions and partnerships that will sustain the economic development. Industrial parks are more than economic infrastructure. They are physical manifestation of our commitment to inclusive industrialization. Our belief that growth and sustainability can go hand in hand. Let us seize this opportunity to make every industrial park a symbol of progress, a place where innovation thrives, jobs are created, and South Africa's promise is fulfilled. Ladies and gentlemen, I thank you.
Thank you, Mr. Molefani. And I've actually asked for a copy of that speech because it was really, really nicely phrased, really nicely encapsulated. Thank you, sir. Thank you for that. And thank you to our previous speakers for being succinct, for being interesting, and for actually catching up the time that we lost when we had to start late due to weather delays. So the next item on the agenda is where we're going to invite experts in energy, and energy particularly in industrial spaces, to join us on stage. So if I can ask the members of the panel, Faith Mkenge, who else is here, Chris, and Kitesa, if I could ask you guys to come and take a seat here. The next part of the program is going to be led very ably by the head of the CSIR's Energy Centre, Dr. Thabo Tlalele. And if you could come and join me, Thabo and his team have very ably assisted the G20 efforts around energy, around particularly energy in industrial spaces, and they will be unpacking some of those learnings, some of those insights, as well as the legacy that was signed, or the legacy commitments that were signed at G20 recently. Thabo, over to you, sir.
Thank you, Julie, and good morning, everyone. Please take your seats. Take your seats. Perhaps as a starting point, allow me to welcome everyone, and I think that has already been done by the ones that came before me. So without wasting too much time, I believe it might be important to sort of give you an overview of what you're trying to achieve. The first part is around giving a sort of overview of sustainable industrial spaces with a focus on energy systems. And this is purely to at least help the audience to sort of understand the key points that we'll be discussing. We'll then go to the next part where then we will have a sort of a Q&A where I'll be engaging with the panelists. And of course, if time permits, we'll allow for a few questions from the audience, sort of to get inputs from everyone else that is here. Without further ado, colleagues, perhaps let me highlight the focus on industrial spaces with a focus on energy systems. And I want to perhaps give you a typical overview in terms of the trends that we are seeing in the space, particularly from the energy part, as well as the industrial hubs. And with that, maybe one thing that we have seen over the last decade or so is in 2024, there was a global energy demand that has increased, and in total, that was about 2.2%. Maybe allow me to also acknowledge that this work was also done by the IEA as part of the G20 presidency. So I thought it would be interesting just to give you a picture of how that looks like, instead of duplicating the work that has already been done. In a similar sense, around 2024, we've also seen an increase in the global GDP by 3.2%. Important to highlight that this energy demand was largely driven by electricity. And as you can see, the electricity demand increased by 4.3%, which is quite significant overall. With that, if you look at the overall mix, you are seeing renewables having about 38% share of that demand, nuclear having 8%, natural gas, coal, and oil. And as you can see, renewables keep on exceeding expectation. And this is largely due to the economies of scale that we've seen over the years, where the cost of renewables such as solar PV as well as wind have drastically reduced over the years. And it is no surprise that they contributed 38% of that overall. Having said that, we are also seeing that the deployment of most of the clean energy technologies remain strong. And if you look at from 2019 all the way to 2024, just on solar alone, there's been an increase of about 27%, which is quite significant. What is interesting to see here is in a similar length, we've seen a significant increase in terms of nuclear. Which was not ordinarily expected, but you can see a 33% increase in that regard. The last two parts, largely electric cars and heat pumps. Heat pumps, I know that in Europe they are quite significant, but for South African and African space, we haven't seen much in that. But you can see that there has been indeed a significant increase. Of course, the heat pump, there is that marginal decrease of about 1%. And of course, these are some of the clean technologies that have been deployed over the years, and we are seeing that they will continue increasing. Again, echoing the same sentiments that you saw in the first slide, where 38% of that came from renewables. Now, what are we seeing on the other hand in terms of the investment, particularly technology manufacturing? There is indeed some sort of increase and improvement, largely driven by a number of technologies. So if you look at just the solar PV aspect, there is indeed a difference in terms of concentration. On the one hand, a significant amount of activities is happening around the Asian countries, with very minimal action happening in Africa. As you can see that there's only a few dots there, one being the towers for the nacelles, for the towers for the wind turbines, and the other part being the, the cell assembly that you would probably get for batteries. Be that as it may, there is indeed a significant amount of clean energy manufacturing facilities that are operational across the globe, as you can see them there. Now, how does this fit into the overall picture from an African context? In the same period between 2022 to 2024, we've seen a significant amount of imports pertaining to electric vehicles, lithium-ion batteries, as well as other technologies, as you can see, there's solar PV and all that. And all that essentially translates into about 266 billion in terms of the raw material that has been exported compared to the imported value of about 4 billion. And again, this seeks to also highlight the importance of having local manufacturing, which was also highlighted in the previous slide, where you only saw a small concentration in Africa, particularly in South Africa. The rest was not there. So there is indeed that need for having manufacturing capabilities. And this is where your SEZs play a significant role. Now, if you look at the local context, what are we seeing? We know that the main drivers pertaining to energy access are largely around the transition, sustainability, and technologies. And all these are the drivers that are essential to ultimately get us to a low carbon pathway, particularly in the energy space. And we are seeing that technology being the main driver for that. And of course, the transition driven by decarbonization, decentralization, as well as digitalization that is required for that. And safe to highlight that research and development innovation will play a critical role in the transition of our economy. In a similar sense, if you look at the overall electricity landscape or electricity landscape in the country, you can see that South Africa is still largely dominated by existing coal fossil fuel. We have seen a significant improvement there and there in terms of other renewable energy resources, but largely so based on the 2024 data, 80% of our electricity still came from coal. And of course, the intention is to decarbonize that and ultimately get to a low carbon pathway. And these industrial hubs, industrial sectors will play a significant role in terms of decarbonizing that. Maybe just to highlight another important point, in terms of the greenhouse gas emissions of the country, particularly in South Africa, we know that electricity is the main contributor, followed by industry. And it is from that note that industry will play a significant role in terms of changing this picture as we move forward. Now, I think most of you who are interested in energy would have heard from the news yesterday when the minister announced a very ambitious target in terms of getting South Africa back on track in terms of its number one NDC requirements, but more importantly, energy security. And you would have seen that there's a significant ambition in terms of clean energy technologies. Safe to highlight a few points. The target is to get about 25 gigawatt of solar PV by 2039. And of course, this is done in phases. And of course, you're also seeing the likes of wind as well as batteries. And interesting to highlight, the embedded generation is also included there, which is basically the behind the meter solutions. And all these, we are seeing them as will play as critical, that will be playing a critical role towards number one, decarbonizing the electricity sector, but over and above that, enabling industry to thrive in the long term. So these are some of the key numbers that we are seeing that we anticipate will translate into the industry as a whole. So what are we seeing from the industrial parks perspective? We did a thorough analysis, and I'm sure Dr. Roro will also give some view on the sustainable industrial hubs. Important to highlight is that emerging and operational sustainable industrial hubs across the globe. As you can see, the one in the Eastern Cape or the East London Industrial Development Zone focuses on eco-industrial park, integrating renewable energy and circular economy practices. In a similar sense, if you also look at another one in Atlantis, it focuses on clean tech manufacturing hubs for solar PV and water efficient technologies. And all these are very important as it seeks to create jobs in the industry. And if you look at the likes of, for example, in Saudi Arabia, NEON focuses on hydrogen project. They want to export hydrogen. And there's various other regions that have different targets in terms of their hubs. And this concept of hubs is not necessarily just on the energy aspect, but also creating manufacturing opportunities that are in line with clean energy technology. So this is what we are starting to see from a global picture in terms of what's happening in this space. Locally, what are those drivers that are helping us to ultimately achieve that? We've got a number of policy documents that are helping us with that. Number one being the, of course, because we're coming from the science, technology, and innovation space, the decadal plan, right? It has intention to accelerate renewable energy through the hubs and spokes model, hydrogen deployment, as well as energy storage, RDI, and carbon capture. In a similar sense, most of you are aware of this hydrogen society roadmap that really unlocked a number of opportunities, including the commercialization strategy that you're now seeing being implemented. But important to highlight the importance of the South African Renewable Energy Master Plan with a focus on renewable energy technologies and driving industrialization. So the hubs will ultimately rely on these already existing policies to get them to be operationalized. In a similar sense, we are aware that decarbonization, particularly in the hubs, will rely on cross-sector collaboration to unlock shared value. There's already a number of strategic infrastructure projects that have been outlined, and of course these are greenfield projects that we believe the hubs can ultimately help to achieve that. Number one, if you think about the technology development, industrial spaces are high energy consumers and therefore can serve as concentrated hubs for number one, renewable energy integration and allowing economies of scale in clean energy infrastructure. And in a similar sense, industrial hubs can serve as innovative ecosystem to integrate R&D, technology incubation, as well as local manufacturing. These are some of the things that we envisage that would come out of the hubs. Of course, in terms of industry focus, where we think that the importance of national strategies that must align with industrial development and energy transition goals to ensure resilient and long-term growth. And the examples is the recent IRP, as well as the hydrogen society roadmaps, including the SRM, just to mention a few. And while we're doing that, it's important to also highlight the importance of capacity building, essentially meaning that the transition must create shared benefits as well as local capabilities. So what are we saying when we talk about this? Before I allow the panelists to sort of reflect on some of the points, Collaboration is essential. Collaboration must be built between facilities to enable joint research and development, knowledge exchange and setting the standards. Technology, energy efficiency, and renewable energy integration is important in that it is driving decarbonization through innovation and operational efficiency. Ultimately, that will require energy efficiency, on-site renewable, be it behind the meter or actually deployed as part of in front of the meter. And of course, the other point around industrial zones can act as innovation clusters, which I think the members will also, the panelists will also elaborate more on that. From a policy enablement, it is important to highlight the policy alignment and how industrial clusters can ultimately help to achieve that. But importantly, to highlight that industrial zones can serve as test beds for clean energy policies and infrastructure pilots. And of course, the last but not least, funding mechanism in terms of unlocking in terms of unlocking finance to decarbonize industrial spaces. Now, having said that, allow me then to maybe go back to the original part and really engage with the panelists and try and understand their reflections and also give them the opportunity to introduce themselves. So allow me to then, to the panelists, maybe in terms of responding, I'd like you to briefly highlight who you are, your role, what you do, and of course respond to the question that I want to sort of place to you. Having seen the presentation that I've sort of outlined, let me maybe start with Mshenge. How do industrial spaces contribute to national energy systems, and why are they critical in achieving decarbonization targets?
Thanks, moderator. Just as a way of introduction, my name is Mshenge Nyoga. Yeah, there's a click there. So I'm a national project coordinator based at the UNIDO Regional Office of Southern Africa, responsible for the energy and climate action portfolio in South Africa and other countries in the SADC region. We do a lot of work around special economic zones and industrial parks, or to more inclusive industrial spaces, looking at energy, optimization, and also energy supply, looking at just the draining of the electricity mix that goes into these industrial zones. So I think you've already touched on the characteristic of an industrial space, in that it's I'll term it as a high energy consumer, in that I would even probably extend it and say these are usually concentrated areas where you find energy being consumed at high intensities, looking at the makeup of the companies that are there. So in terms of contributing to the national energy systems, in a report that was done by the IPCC, it was recognized that industrial spaces could play a critical role in decarbonization due to the fact that you are looking at companies that are located in close proximity and share infrastructure. So instead of dealing with just specific companies, you could just look at decarbonization through this system that exists. So they do offer a lot of advantages. One, you could aggregate demand and make projects more bankable if you're looking at investing in renewable energy. But at the same time, because you've got a number of industries located within this zone, there's that concept of predictable energy profile, or energy consumption profile, which in itself offers another advantage on how you could optimize energy consumption and also deploy renewable energy. So with that, you could look at the potential role that they could play around the energy system in two ways. One, it's on the uptake of renewable energy, looking at the supply of the electrons, but at the same time, you could look at it from the point of the supply of manufacturing of technologies that go into to support the national interventions around energy. And second to that, because you could look at aggregating the demand and deploy renewable energy, there is a case where you could make that some of these zones could be capable in themselves in sourcing renewable energy for their tenants. In that way, they could sort of resemble some form of an energy company themselves. And if capacitated correctly, they could handle all procurement on behalf of the energy of all the companies that are located within the zone. So they do offer a lot of benefits in that regard. And they could have also the advantage of actually deploying their own, I would say, demand response measures on behalf of the municipalities. There's a couple of them that I could touch on, but also looking at the slides that you've shared, especially around the distributed generation targets that have been shared in the RP. So these zones could actually be one of the key deployers of that technology. And in South Africa, there's a number of them. I know we've got about 11 SEZs that are operational and 27 in all industrial parks and other private-owned industrial spaces. So that is a lot of demand that is there that could be served, either with behind-the-meter interventions, but also if you're looking at supporting some of the projects that are coming through the transmission development plan, if those projects are to be bankable, there needs to be identification of the demand centers. And these zones can potentially be one of those that could be looked at as off-takers of the projects, of the energy, but also make sense of the investments that can be made either at a distribution level or at a transmission level. So I'll just, stop there.
Yeah, thanks, Mtlenge. Very elaborate and detailed in terms of what, how they can contribute and participate in this. Particularly, you mentioned the shared infrastructure and predictability of the profile, which unlocks various other opportunities. Maybe just to move forward and maybe get some sort of input from Faith. How do you balance industrial growth with pressing needs for energy efficiency and reduced emissions?
Thank you for that question, but by way of introduction, you asked us to introduce ourselves first. Good morning, my name is Faith Mkajwa. I am an executive responsible for energy efficiency and demand-side management at SANEDI. As you know, SANEDI has a legislative mandate to resolve or try and assist to resolve energy challenges. But with that comes the responsibility of also looking at the socio-economic challenges as part of resolving that challenge. But also at SANEDI, we see the challenge as very unique. So, and I've always insisted that the African challenge is very unique in the sense that it's not just about decarbonization. It's also about making sure that we have reliable electricity or energy, but also if an ordinary South African can afford it, because it's one thing to have reliability supply of energy, but it's one thing for an ordinary South African to be able to afford that energy. So even when it comes to industry, we also look at it in the same fashion. So just to try and marry decarbonization and energy efficiency, I did say that we look at it as one coin, two sides. So there's the reliability side, or making sure that we 100% connect everybody to electricity in South Africa. And then on the other side, there's the decarbonization. And I believe, without a doubt, given my experience and the stats that some of you of which you've shared today, that energy efficiency can make a meaningful contribution towards decarbonization in South Africa, but also it can drive down cost. So if you also look, if we move to industrial spaces, then I've heard a lot of people say, but industrial parks in South Africa don't actually make that much of a contribution in terms of consumption. Yes, you may be onto something with regard to that, but you cannot look at it as a single incentive for actually driving efficiency in the industrial spaces. So yes, if you park that aside, you also realize that we've got what we call the NEES, or the National Energy Efficiency Strategy, post-2015. And in that NEES, we have a target for 2030. And we have sectoral targets. So first off, we've got 15% for industry. And that is because industry has come a long way and they've made strides specifically in energy efficiency. And then we've got 37%. And that is for commercial buildings. So what makes industrial spaces unique is that they have both. So there's the industrial aspect and then there's the commercial aspect. So what we are doing at SANEDI is drive both and of course bring in the socio-economic aspect of it. These industrial spaces are located in communities that have suffered previously. If you look at Bebelechi, it might seem like economic to you, but it's a lot more than just economic. If you look at industrial spaces that are probably based in Prospecton, there was a risk that nobody highlighted and nobody actually addressed. They were vulnerable to climate change. That risk was never addressed. Had it been addressed, those industrial zones wouldn't have suffered as a result. So there's a lot of things that we can unpack when it comes to industry, more than just being the significant energy users. Of course, they utilize energy and they need reliability of supply. But then the other thing is that we cannot forget that this is where they suffered the most post-COVID. So the load sheddings that the rolling, some people call it the rolling blackouts, but load shedding in simple terms has affected them the most before they could even recover from the impact of COVID. So for us, we bring that thinking that yes, it's an energy challenge, but it's also a very realistic socio-economic challenge and a decarbonization challenge in South Africa. And for that, we drive regulatory frameworks such as the EPC regulation, which is a 2022 regulation, which is a regulation that was promulgated in 2022. So SANEDI, as the implementation agency of the Department of Electricity and Agency, we are implementing that, and it's reaching its 5th year. What that does is make sure that you keep an eye on buildings, because there's an opportunity for energy efficiency in buildings. And of course, we drive incentives, because these organizations, those businesses that operate from industrial park needs a bit of support. So incentives assist when it comes to that support. So we offer what we call the 12L tax incentive. In simple terms, you can call it a tax rebate. So it goes a long way. Once you can demonstrate and you have verifiable savings, we are able to give you a tax break through the National Treasury and of course through SARS. And then lastly, we have what we call ESCOs, Energy Services Companies. They play a crucial role, because as much as SANEDI and government want to create jobs, there's only so many jobs you can create. And we acknowledge that that is part of a big problem in South Africa, particularly in industrial spaces. So if we have ESCOs that, number one, operate from the spaces, but also ESCOs that also service the spaces, we have a full economic cycle that actually drives that. And in the center of it is actually energy and energy efficiency. So we find that is quite key, because ESCOs, when we support them, we call it ESCO market development. When we support ESCOs, they move from becoming one-man show to 10-man show to employing 100 people. So they create employment while also addressing energy challenges and, of course, addressing the socio-economic challenges. Some of them, like Nkanya said, they can actually participate in the renewable energy value chain in the same industrial parks. So when you speak about reforms in the industrial parks, the story is not done if you haven't spoken the story of decarbonization, if you haven't spoken the story of sustainability, if you haven't spoken the story of energy efficiency. And I think that is where SANEDI comes in. Be it training, be it incentives, be it regulatory framework, which we implement on the behalf of the Department of Electricity and Energy. We are there to assist and make sure that these industrial parks once again thrive, and they move away from the previous failures, so to say. And it saddens me to say this, but that's where we found ourselves in South Africa. But it is an opportunity to do that, to revive everything from the renewable energy aspect to energy efficiency. Of course, I cannot speak to them about energy efficiency if they're not fully operational. So before they are fully operational, I need to support them through ESCOs. I need to support them through incentives. And then I can enforce and partner with them on industrial energy efficiency. Thank you.
Great, thank you very much for that. And speaking about opportunities and challenges, I'd like to maybe turn to you, Dr. Chris. And really, can you maybe just give us what are those challenges and opportunities for localizing renewable energy technologies, manufacturing within industrial hubs? And I believe that you're from one of the IDZ, so perhaps you have a much better appreciation for that.
Yeah, thank you. So it's Chris Etmeyer with the East London Industrial Development Zone, and I perform a business development function as a sector manager, but I think nowadays with flexible workforces and expectations, I'm also a counsellor, lawyer, psychologist, coffee maker. So, but yeah, I think the localization, we've seen actually a couple of companies come and go in the IDZ itself, as well as in South Africa in general. I think there's quite a few different challenges. So, you know, I saw access to finance coming up there. That's one of the key criteria and getting that, but also establishing a big enough market in order to serve. So, South Africa is a good market and big, but you need to look up into the rest of Africa just to make sure that you've got that sustainability built into it. There's policy uncertainty. We've also seen a lot of companies, a lot of interest and hype being generated. We saw it, when in 2015, South Africa said they're going to be blending for biofuel. So all the biofuel companies were there, do detailed studies, everyone's ready to set up, you start getting licenses and permits, and then the legislation just isn't sort of rolled out. We're seeing now again a lot of biofuel companies coming to us and a lot of excitement because there's the legislation coming again. So I think that policy uncertainty, we've seen it with electric vehicles as well. South Africa announces a white paper. You get the market excited, everyone comes, and there's a lot of interest and tons of potential, and you all start aligning and getting ready. But when it doesn't follow through and push through, that uncertainty creates a lot of challenges in trying to set up for local content. On the skills development side as well, you've got to have a big picture, and you almost need a little bit of time and foresight to get all the different pieces of the puzzle together before rolling out something. So to insist on local content is good, but you've got to make sure, do you have the raw material supply? Do you have the companies that could actually make the products that you're going to ask in local content? So you've got to do that, and we create all those skills through our science and technology park. So we roll out quite a few skills development programs. So yeah, there's quite a few combination of different things that are important. And then once you start with local suppliers and you've got them up and running, it's a pity if you change your mind and then sort of drop that sector again. You've got to have that sustained sort of demand in order to keep the guys going. And then again, I think the member from the DTIC is also just talking about that market access and looking at the export markets. That's what these special economic zones are designed to do, is look at local manufacturing with an objective of exporting. So you have to make sure that that market access will help sustain that business. Thanks.
Yeah, thanks, Chris. And maybe then just to move to Dr. Roro, you have been very close to the activities happening under the Energy Transition Working Group, but equally so, you are leading the work that's happening under, technology optimization as far as renewable energies are concerned. Maybe just a quick one. How can renewable energy technologies such as solar, wind, hydrogen be effectively integrated into the industrial operation?
Thank you. That's a nice question, Tabo. My name is Kete Saroro. I'm the research group leader for energy supply and demand within the Energy Center at the CSIR. And I was co-lead for Sustainable Industrialization Hubs work stream in G20 Energy Transition Working Group. So the effective integration of renewable energy technologies such as solar, wind, and sustainable hydrogen into industrial operation requires a systematic approach. The first one is integrated energy planning and system design, where you not only plan for electricity, but also for include heat transport as well as industrial development. The second one is sustainable hydrogen as a feedstock and energy carrier. Yes, we all know that hydrogen plays a pivotal role in decarbonizing hard-to-abate sectors, such as steel, cement, chemicals, and heavy transport. By coupling renewable electricity with electrolyzers, industries can produce sustainably generated hydrogen. The second one is electrification and process optimization. Where feasible, industrial operations should prioritize direct electrification using renewable powers. The third one is infrastructure and grid integration. The effective integration of renewables into industrial hubs require modern grid infrastructure coupled capable of handling distributed and intermittent generation. The other one is policy and regulatory enablers. Enabling frameworks are critical. Policies that promote open grid access, wheeling arrangement, and renewable power purchase agreement can empower industries to directly procure renewable energies. Of course, you have touched on it. Investment and finance mechanisms also required. And the last one, I think other speakers also touched, skill development and local value chains are important. In summary, integrating solar, wind, and sustainable hydrogen into industrial operation is not merely a technical exercise. It is a strategic transformation that enables competitiveness, reduce emission, and business resilience by combining innovation, capabling policy, and coordinated investment. Sustainable industrial transformation can happen. Thanks.
Thank you, Kitesa. And you've touched on a number of important points, particularly the systems approach that needs to be incorporated, which I think is quite essential. I'd like to move to the next set of Q&A to the panelists, and maybe just to reflect again, Mshenge, everyone else has gone around highlighting localization, skills development, and earlier on you mentioned the importance of how these industrial parks can de-risk some of the investment, right? And I don't want you to touch on that again. In your position, you sort of have a broader perspective to this context, and I want you to maybe reflect on the lessons learned that can be drawn from global examples where industrial zones have successfully integrated sustainable energy solutions. So at least give us that bigger picture from a global perspective.
No, thanks, moderator. Yeah, I mean, there's a couple of lessons that have come through at a global level. I believe some of them you already captured them in that slide that captured the various industrial spaces that have done renewable energy integration with cases from Denmark, Kalundborg, Osan, Korea. One of the key lessons that have come through even in literature, outside of just the practical examples, one, collaborative governance was one of the key things. So there's a number of models that have been implemented to look at integration of renewable energy within these industrial zones. Industrial symbiosis was one, looking at the exchange of energy between firms that are located within the same zone, and also looking at how those integrate with the urban system as well, just moving from basically looking at the urban industrial nexus. So some of those have shown that collaborative governance is one of the key things that need to be looked at. Also, energy cooperation within the special economic zones or industrial zones has been highlighted as one of the key measures. And the reason I'm saying this is because there is a need for trust between the players that are actively participating in development of these projects within the zones themselves. And that, in most cases, can either be done if there's an entity that is coordinating and responsible for coordinating the projects, including co-development of projects within the zones. That is getting alignment between the companies that want to, let's say, look at shared solar projects or shared biogas projects. So there has to be an entity that is responsible for that, to look at getting everyone in line and have terms that are clearly articulated of who takes what percentage of, for instance, the solar that is being deployed or the biogas project that is being implemented. And also shared infrastructure, I think I've touched on that quite a bit. It's something that has to be developed quite in a coordinated fashion, and also this also links to that collaborative governance, because you'd find that in some cases, yes, you've got the zone and the management entity responsible for managing the space and basically handling the operations, but the grid infrastructure, be it electricity, be it gas, is actually managed by either the municipality or utility. So in cases where you now have to integrate the energy sources, there are cases where the grid capacity is not sufficient, and that role might not lie as a responsibility of the management entity, but a municipality or a utility. So in that case, you need to look at how do you create that relationship between the management entity and the municipality or the utility, in that They could come in from a public funding point of view to fund the grid infrastructure, and then private generation assets could be funded by the management entity in collaboration with the tenant companies. So there's that relationship that needs to be sorted out if projects are to scale. Policy enablers, I think Dr. Rora had touched on them. So there's also a need for clarity in terms of, I'll bring it closer to home. If you look at the PFMA and the role that it plays in actually managing the financial system, if I may put it like that, within the industrial zone, there needs to be clarity on the type of partnerships that could be implemented to assist with the development of these projects. Globally, I mean, there are lessons that could be drawn and how those could be set up. Of course, they would need to be adapted to the local realities. But that has to be clarified because the ESCO conversation actually feeds into that. Because if you look at the special economic zones, industrial zones, especially those that are public owned, yes, companies come in and operate. However, I mean, the responsibility of who pays electricity lies with the company, not the management entity, but the management entity owns the structures in some instances. So that role and responsibility needs to be clarified, and that's where things like the PFMA and possibly SSA Act will come in and clarify that. Permitting of projects as well needs to be streamlined such that these projects, it's a way of de-risking the project, I would say. Longer permitting processes and the type of licenses that need to be put in place. There's a lot of that could be said as how that could be facilitated. And central to this, I'll be biased and say you still need that coordinating unit to handle that on behalf of all these companies that are located within these industrial spaces. Because the companies themselves are not in the business of generating electricity or energy. They're in the business of selling whatever product they are doing, that they're interested in. But the responsibility of the utility supply could be another person's responsibility. I'm not saying that it should be solely the responsibility of the management entity, but there has to be a partnership that has to be established between the management entity, which in most cases is public owned, but also with the private sector. So we need to work on that. And I mean, there's examples, renewable energy cooperation projects have been implemented mostly in the European region. There's been community solar projects as well that have been implemented. So lessons from that could be drawn to see how industrial zones could scale renewable energy integration. And also, I think there's a case to actually map the energy consumption patterns within the zones themselves. Of course, I know you might not speak directly to the project, but if we are going to argue electrification in industrial zones, we need to understand the final energy consumption within the zones itself, because not all processes could be electrified. So I think there's that case that needs to be made. I'll just stop there. Thanks.
Yeah, thank you very much, Mklenge. I got it right this time. Maybe just to then move on, but I think the critical point that you're highlighting here, collaboration is key. And that's what you've learned internationally, and this can also be applied here at home. Earlier on, Faith, you highlighted, you gave some good numbers around, for example, the targets for industry in terms of energy efficiency and commercial stuff, 15 and 37%. Now, I'd like to maybe just get some sort of, let's make it much more practical. What are those practical steps that industrial parks can take to improve energy efficiency and reduce operational emissions? What are those practical things that we can take? Because, target 15%, 37%, but how do we get there?
Yeah, so there's a myriad of things that they could do, and I think capacity building would be a very good starting point to capacitate them to do it themselves instead of relying on external service providers just for the sustainability aspect of it. But then, standards like ISO 50001 offers energy management systems that you could take and implement whether you want to go for certification or not and still benefit. You could also look at making sure that, going back to Mklenge's point, you understand what the real user requirement is for the different processes. I think especially the older ones, we have a lot of issues of oversizing in industry in general, not just in industrial park. So that's a very serious issue. I don't know what was that about older engineers, and I'm I'm probably one of those older engineers, but not that old. I think the idea of oversizing was trying to foresee and predict that you will need to grow as a business, therefore you will need additional capacity. But over time, as efficiency found its way, as technology and processes became simpler and streamlined, there was no need to actually grow in terms of consumption. Rather, everything became centralized and everything became, I mean, the Japanese did it a long time ago, I mean, with just-in-time processes. So that has found its way in every aspect of the economy and industry as well. And what do you find? You find that actually you don't need the oversized pump, the oversized motor, the oversized equipment that actually still lie in industry and industrial parks today. So I think we need to start there. If we understand what the real user requirement is, then we can replace them with the correct size of that equipment, and by that you automatically make a huge saving. And then we move on to what we call end user. So this is when you are running your processes, whether it's renewable energy or obviously a coal or fossil fuel based electricity. And now you have to there's a huge behavioral aspect of it, which by training, awareness raising, and simply making sure that there are steps and processes that you follow as part of how you run your business. But also make sure that you also build that into the strategy. I've found that in industry, we have the company strategy or the organizational strategy, and then we've got a little energy strategy on the side. That is never gonna work, especially if you are very intentional and serious about actually seeing a difference. And if needs be, because everything else on the organizational strategy is termed in rands and cents, yet energy is still named in kilowatt hours. And so maybe that's really where the disconnection is. Bring it to merge with the organizational strategy and then translate that, because energy savings, as Ndibo has showed, you can translate that into rands and cents. So if you need that, and then bring it to the fore and make it part of the organizational strategy. And I believe that is the only way you can make it ongoing. You can sustain the savings and make sure that as and when you plan, whether you're growing, whether you're changing, whether you're operationalizing new systems and processes in your business, energy is incorporated in all of those. So I can speak for days around those, but I think energy management, in short, there are policies and systems that speak to that. Some of them are for compliance, but if you look at EPC, for example, it is purely for compliance, but it's got an energy saving component as well. So take policies and regulation and use them to empower your business as well. It's not just for compliance. If you only look at them for compliance, then it's not going to do, it's going to be seen like a burden for you and your employees. So I think that, in a nutshell, will be some of the tools that are readily available today that industrial organizations based in the industrial parks can actually incorporate and start implementing some of those.
Yeah. No, that's excellent. I can't say it any better than the way you've said it. So to try and summarize it might not be so good. Maybe let me move to the next step and allow Chris to come in. Chris, earlier on you mentioned opportunities and challenges that are being faced within the IDZ. I'd like to maybe just ask you to now that you know those opportunities and challenges, can you reflect on what would a fully decarbonized, energy-efficient industrial park zone look like in the next 10 to 15 years? You've got the historical evidence and lessons learned, but how does that look like as we move forward?
Thank you. So we don't always get nice questions sitting on a panel, but this one was actually great because you sit and you work and you're in the trenches, you're doing these projects, and you remember you're doing it for a reason. But this question, I actually sat back and thought, it was actually nice to reflect on why we started doing all these things that we're doing. But I think the East London IDZ, we've got some very good ideas, and that came from a lot of research that we've done in the past, together with collaboration and partners like CSIR, NCPC, UNIDO. We're now doing studies with Senedi. We've got the GIZ, the German Business Chamber. So there's quite a few things that we're doing, and that collaboration is very important. But I think, when you drive down to the East London IDZ and you see all the factories in front of you, I think the first thing that must strike you is that there must have been some kind of design or plan behind it. And I think later on we're going to hear from UNIDO about master planning and how important it is, but it doesn't help when you have consumers of steam dotted all over your industrial park. You have to cluster them together to get those efficiencies going. And it's something to help the sustainability of your tenants so that they can keep affording to pay you your rentals that you ask for them every month. But it's also a revenue stream for SEZs to have. So we sell water and electricity to our tenants. We don't sell steam. And now the question is, wait, we should be selling steam and possibly green steam. So it helps with your sustainability, but it helps with your tenant sustainability. So that's very important. And I think when I look into the future and trying to imagine what our industrial park will look like in 10 to 15 years, so firstly, you should be seeing solar everywhere, probably micro wind turbines, hopefully bigger turbines if our airport can upgrade their radar. You would see biodigestion taking place. You would see centralized wastewater treatment. You would be reclaiming, so there would be rain tanks. We've got our water specialist here as well that's helping us with water studies now. But you'll see rainwater harvesting. You will see when you've got your green hydrogen project, you're going to oversize that so you can use desalinated water in your system as well. So you, as an SEZ, you would have security of supply of all your utilities, which is very important. But I think further to that, there's so many more areas that you can actually be creative on. From supply chain, we could be sourcing from women-owned businesses, youth-owned SMMEs, and also sustainable businesses that report their ESG scores. And you know what that company's carbon footprint is, because ultimately my tenants need to know that because they're trying to export into Europe. So you have to have that. I think smarter buildings. So our buildings, we're trying to throw technology into it, mainly because we built a big data center. Now we need data to be going through that center. But if my tenant gets an alert on a WhatsApp and says, hey, your factory's consuming water, but it's Sunday, and you don't have production on Sundays usually, that automated sort of intelligence should be built into the system to say, wait, there's something wrong here. So we're trying to look at how to make smarter buildings and smarter utilities and just that early warning. So that fits into our smart industrial park concept. And again, that's something you can push out into a smart city environment. Or you could take this to our other SEZs that we don't always compete. We also can share information and knowledge. And then, just lastly, I think that we've got that scale and that ability to be big enough. Our excess water or excess renewable energy can also go to our local community. We've got excess internet that we don't always use. That could go into community programs. So you just also forge a better working relationship and community sort of collaboration. And then you also just bring that knowledge into the community to highlight opportunities for further development. So I think that's the kind of space that you would look at industrial parks, and it would be something that you could just see is very advanced and sophisticated in the future. Thanks.
Yeah. No, thanks for that, Chris, for painting that picture. I hope investors are in the house so that they can invest and put money into realizing that 10 to 15 years vision. Having said that, Kitesa, you were saying earlier on that you led the G20 energy transition outcome one. I think it's on sustainable industrial hubs, if I'm not mistaken. And you had a rare opportunity of being part of that whole process and sort of getting what the policymakers are debating and how do we take that forward. Can you maybe just give us your view of how can national policy framework, right, there's so many different frameworks, align with global initiatives such as the one that we just saw now in terms of the G20 Sustainable Industrial Hubs, with the intention to accelerate and decarbonize the industrial sector and ultimately reach a low-carbon economy?
Thank you, Thabo. This is a very important question. because alignment between national policy frameworks and global initiatives such as the G20 Sustainable Industrialization Hubs is very essential. Let me get my notes a bit, sorry. At national level, policies set the enabling environment, defining investment rules, industrial incentives, and energy priorities. At a global level, initiatives such as Sustainable Industrialization Hub bring shared principle, finance mechanisms, and knowledge partnership. The two must work in hand. So that's the first important thing. First, national government can align embedding principles such as sustainability, inclusive, and resilience into the industrial and energy policies. This ensures local industrial strategies contribute to global sustainability topic objectives which reflect each country's development context. The second one is policy coherence, which is a key. Countries should harmonize the industrial, energy, trade, and environmental policies to support integrate low carbon industrialization. The third one is alignment to create investment-ready ecosystem that mirrors the global framework. Finally, initiatives such as Sustainable Industrialization Hubs Coalition provide a platform for knowledge exchange, capacity building, and project matchmaking. In short, national framework must not operate in isolation. They should translate global ambition into local action. Thanks.
Excellent. Indeed, we should not operate in isolation. Now, we've gotten to a point where, we've provided so much information to the audience, and I'd like to take this opportunity to sort of get 2 or 3 reflections from the audience, questions, comments, concerns, so that we can at least make this as more impactful as we can. Are there any questions in the room that you'd like to ask, be it the presentation or the remarks from the panelists? I can see one hand there, and then I'll come back to you. Yeah. Maybe just state your name, where you're from, and of course, if you've got a particular question that you're directing to any one of the panelists, or even myself.
Okay, I see the mics are not working, and this is an online question. This is a question from the online audience. Greetings, how would sustainable industrial spaces participate in the South African wholesale electricity market?
Perfect. Let's take another question before we... Yep.
Dr. Chris, thank you. I found what you were sharing very interesting. There's always a focus on electricity, and that is one's Scope 2 emissions, but it's hard to decarbonize one's Scope 1 emissions. And yet that's what South African industry is taxed on, and that is not very low-hanging fruit. There aren't a lot of alternatives to coal, HFO, paraffin-fired boilers. In the East London IDZ, what do you see as the potential solutions? What do you see as the potential technologies that you would like to see industrial steam generated from to help industry decarbonize, specifically in South Africa?
Perfect. I'm not seeing any other questions. Perhaps let's start with the first one. Mshinge, I'm sure you'd be keen to respond to the first one, because I know we briefly had a discussion about this not so long ago.
Okay. Participation of SCZs and industrial zones in the wholesale market. Interesting question. So there is a project that UNIDO is implementing in South Africa, funded by the government of Flanders, which seeks to look at that particular topic, recognizing the amended Electricity Regulation Act in South Africa. And following the discussion that we had with Thabo when we had the project steering committee meeting for this project last week, I mean, there's many opportunities that we see. One of them is basically how do you capacitate SEZ management entities to be able to interact with the market? This could be through bilateral contracts that exist between the SEZs and the wholesale operator, if I may put it that way. But there was also an interesting point to see how we could actualize or demonstrate distribution system operators and the role that these SEZ companies could play as one of the demonstration sites for that. So it's something that we are going to look at studying through this project and have some recommendations on how these SEZs and industrial zones could position themselves as one of the key market participants in that regard. But yeah, it's still unanswered, but answers will be provided. But there's potential, especially if you look at bilateral contracts that could be that could exist. And the question is now, what are the limitations? What needs to be put in place for SEZs and industrial zone management entities to be able to carry out that responsibility, and the type of partnerships that would need to exist in that? Yes.
Great. Perhaps before we move on, is there anyone that would also like to pitch in on that? Please.
Yeah, I think I must also just share what we're doing, because we've got transaction advisors again now. So this is support from the British High Commission. So we kind of pimp ourselves out to anyone that's quite keen to help us, and again, the collaboration is important. But yeah, we're looking at the formation of an energy special purpose vehicle. So we're working with Kucha, RDZ. I think Atlantis has also got ideas around that, and then the RDC and DBSA. So we are looking at that, and that would almost be an aggregator in the energy market. So a separate legal entity outside of the SEZ. So that is something that we've done quite a bit of research on as well.
Excellent.
I could jump into the next one. Okay, so the question. So yes, we did do an energy master plan where we did quite a bit of modeling, again, supported from the Energy Centre at the CSIR, where we looked at, you kind of get a big 3D map of the low-cost options and easiest and quickest and more cost-effective and the life cycle cost of technologies. So it did give us a mapping list of priorities on what to implement first. So solar PV comes up very quickly with battery. We also got very good wind resources at the East London RDZ. So then your biogas and biomass comes through. So it gives you a nice prioritization of what you should tackle first. And that's we've been guided by that in terms of the master plan for our energy sort of roadmap. We do have a green hydrogen project. So for those that watch the newspaper, our EIA was approved 2 weeks ago. So we're looking at the potential there of decarbonizing, so particularly our investors with boilers, replacement of paraffin, substitution of electricity, moving on to green hydrogen. So that's the kind of areas that we're looking at for decarbonizing.
Excellent, excellent. Are there still any questions from the floor? Yeah, please.
Thank you. Okay, thank you. Thank you very much. My name is Mudiye Mulibatsi. I'm a land surveyor by profession. I get excited when my younger brother there in Diboho invites me to these conferences that he always hosts. I've got a number of things. I'm too excited. Just so you'll have to manage me a little bit. I'm declaring, but first thing I would talk to Ndi and say, Ndi, you mentioned that the 1,000 plus people, professionals that you have trained, have already started moving out of South Africa to other countries, even developed countries. And I'm saying, in South Africa, we really never seize the opportunity. We don't see them, you know, and I'm wondering, why are we not doing this for the whole continent, for the rest of the world? If they can see and poach our own professionals, then damn, we are doing something exceptionally good. So why are we not creating an institution that really goes out to train these people en masse. Remember, you're not training them for the continent, for the country alone. You've realized that there's a market out there that needs your people. Why don't we create an institution? I mean, if you look at, we mostly all of us know the history of MIT. It was a technical. And today it's a sought after, one of the best institutions, technical institutions in the world. Why are we not thinking of creating the same? We already have proof of the pudding. Why are we losing that opportunity? Because somebody's going to close that gap. And we actually need to put ourselves on the map. South Africa used to be there in the past when we were rated high in terms of R&D and all those kinds of things. We have lost our position. But now we are coming back. We hear the good things that have been done. Please, Ndi, money is not a problem. We need a bankable project. If you come up with a bankable institution framework, I guarantee you, I'll get you the money. Secondly, really honestly, you know what frustrates me? I'm sorry, just bear with me. If you need tea, just bear with me. If you look at Ghana, in 2023, Ghana, there was an article in the newspaper, South African newspaper, about Ghana, that Europe is poaching nurses that are trained in Ghana. South Africa used to occupy that space. I know a lot of nurses that went to Saudi Arabia, Middle East, and Europe. They love our graduates because we train them very well. But South Africa lost the opportunity. It's still there, but we are sleeping. We are not waking up to seize opportunities. Ghana has decided, took a conscious decision that it will train nurses and supply the Europe. What? They are making money out of this. It's like they've got an employment agency for these nurses. We have to think about doing similar things so that we can then own that piece of the space in the world and show the world what we are capable of. We tend to undermine our ability and think we are less than thou. And it frustrates the heaven out of me because everywhere I go, I find that there are, every corner of South Africa, we've got exceptionally amazing human beings. So, Nde, it's on you. I'll be on your neck. But coming to Ntate is him? And Memo is from Sadedi. We've got challenges with, I'll talk about my hometown. I come from Welkom. Welkom in the Free State was a mining, it was a coal fields, those towns, the 6 towns that forms Machabi municipality. And you know what happened there is so devastating. When the shafts closed, we lost jobs in the mines, but we also lost jobs in the industrial parks. We also lost jobs in terms of your workers, as in a person who cleans somebody's house or the garden. So you can understand the devastation that we are experiencing in those places. So what I would like to know is, what are you doing? Is there a plan about this? Secondly, do we have a plan to mitigate against mining towns that will be dying? Like we are talking about transition, energy transition. We've got we've got the coal cities and towns. I can see the devastation that's going to happen there. Are we already proactive to say what are we going to do to make sure that those cities are not going to die? So it's on you. And sir, it's London. I studied my degree, I started it at Fort Hare. And my lecturer, I did geography, and when we were doing economic geography, my lecturer took us on an excursion to the harbor. And he kept on saying to us, the harbor is dying, and this is going to devastate East London. At that time, that was, I'm going to expose my age. That was 1988, when I was at Fort Hare. And it worried me since then to say, why are we allowing things to die when we are aware? But where is that awareness coming from strongly? From an institution of higher learning. Now, the challenge that we have in this country, which Minister Mkwinti, when he was the Minister of Rural Development, said he doesn't understand that on the African continent, we do not have cities growing around institutions of higher learning. It is an anomaly because in the rest of the world, a university starts and the city begins. But here, where the universities are, those towns have died. So I will say to you, this is what happened at Fort Hare. One of the guy who's the head of department, Dr. Vabaza Kluza, had a group of master's students who developed the solar panels and they did so well that they were allowed to electrify some RDP houses. But you know what? Fort Hare is sleeping. They don't have an innovative institution that captures this and monetize it. And those kids are gone. We've lost. There was a proof of the pudding. And I'm saying to you, sir, when you have these IDZs, work with institutions of higher learning and also guide, because there's a lot of things that we have spoken about. Somebody must do research. But these kids who are doing science and technology and engineering, they do their thesis in master's and PhD, but when you look at the topics, it's going to collect dust. We want people who do research on things that can be utilized to advance our economy in this country. So please, can you guys include and work with institutions of higher learning? It's a symbiotic relationship to make sure that they learn from you, but they supply you with solutions. Well, I've got a bag full of things. I'm a Mosotho woman, you should understand, so I'll stop there. Thank you.
No. All right, Nokia Lebowa. So let us then briefly touch on the points that May highlighted so that we can wrap up because we're almost out of time.
Okay, so what is happening? Okay, there's a lot that is happening. I think the DTIC would also have some insights to share on that around the revitalization program of industrial spaces that were once functional but now have lost some capabilities. So there's that program that is running within the DTIC, but I will not speak on that because I think the DTIC can represent themselves quite well in that regard. But at the same time, there was a study or an assessment of what to call renewable energy development zones that was done by the DFFE, supported by the CSIR. In that study, I believe Northwest was one of the areas that were located, especially looking at the old mining towns that could be revitalized at the back of the renewable energy value chain, to look at how to localize manufacturers there, but also these sites were identified for priority projects that would fit into the renewable energy independent power producer program. So there is that work that is being done by various institutions. From a UNIDO perspective, I wouldn't say I mean, our work supports the revitalization program, but to speak directly to the needs of old industrial parks, we have not yet started to look at that. For instance, my focus is more on energy supply within the zones, but other colleagues will be looking at other environmental aspects. But from a revitalization point of view, I mean, the DTIC would be one of the key players to engage there. And I see Mr. Tammy Klassen sitting up there. That's the person that would need to engage on that aspect. But there is great potential if we're going to look at reindustrializing as a country and opening up to more opportunities, especially with the transition that is taking place right now. Thanks.
I'll try and keep it short. So I'll answer from the perspective of Sanedi because you specifically said, Sanedi, what are you doing about it? And thank you for invoking what most South Africans are actually going through. And what you just said is a tip of the iceberg. So I'm also going to respond from, before I joined Sanedi, I was a mining executive, and I looked specifically at energy and climate change, 10 mines across the globe, across 6 countries to be specific. And every country is very different, but the worst tend to happen in Africa specifically. Where I used to work, we had mines in South Africa and in West Africa. And in West Africa, particularly in Ghana, you're right, they've gotten something right to make the community shareholders. And these mining houses are listed companies, whether at Toronto Stock Exchange or Johannesburg Stock Exchange or New York Stock Exchange. So they come up with a set of responsibilities around ESG. So when you think about ESG, most of us think about the big S. But there's a small s, which speak to the community, to the local, to the person who was here before the mine started, or the new owner of the mine was there, but who will be there long after the mine has left, and who'll suffer the consequences of whatever the mine, if the mine does not address certain things or is careless in doing certain things. I mean, we know of some of the devastating effects that the mines leave behind if they don't look, for example, at the environmental impact. We know acid mine drainage, what it does to our roads. Even in the cities, we've seen those sinkholes. It is a result of not focusing on responsible mining, so they call it. But when it comes to a town like that, it's an entire village. It's said that South Africa has not land. We did the same. We did that with Belkom before we did that with Komati. It's an entire value chain that got devastated. But what happens now is that those ESG targets are not just targets anymore. They tie them to certain responsibilities that speak to the communities. I spoke about the big S and the small s, and those things in local and international mines, the landscape is starting to change thanks to those responsibilities, because greenwashing is not going to cut it in 2030. Greenwashing is not going to cut it in 2050. So if you want to be seen or to be taken seriously as a mining organization, you also have to look after the community first. Now, in South Africa, things are happening much more slowly. And we try to copy and paste some of the international ways of doing things. If you look at Australia, for example, a mining town is a thriving town. And before I had to even design and finalize a solar farm or a wind farm, I had to speak to and engage the communities. They needed to understand what the impact of it would be, what the benefits for themselves would be. And they're not talking about this technical jargons that you're going to throw at them just to manage them. They're talking about their children and the futures of these children. So it is changing, but I do feel it is changing very slowly. And this is where Sanedi comes in. When we facilitated the IRP and presented it, obviously there's a whole parliamentary process and the NEDLAC process. One of the outcomes was saying, they were saying, you are three big city focused, Johannesburg, Cape Town, and Durban. And you are I forgot the word, it's a political term, I'm not a politician, but we were accused of actually focusing on the technical solutions, and we are so disconnected from the community. I had to look back and realize that they were 100% spot on. And post that session, a recommendation was made. And so far twice, we've met with the community representatives. And for now, I know it's very small and we're off to a slow start given that we're still in talks. I cannot tell you of a single project that we've implemented. But we're getting there because first and foremost, we understand what the issues are, which we probably thought was not our business. But we are having those talks with the communities, and we've been given the responsibility and the task of, number one, finding money. Because we're saying that, well, our budget is for this technical solution and that project, and UNIDO comes with this, GIZ that comes with that, and this is what they want. But they said, Sanedi, we are tasking you, you go look for partners, and you come up with solutions that will speak to these communities that have been devastated, that they have no hope, and you speak about energy as if you don't live and you don't see these communities. So that's something that we are embarking on, but it's fairly new. And I'll be glad to keep in touch with you and maybe to even report it in our annual results. We just reported our annual results, and I think these are the stories that we need to tell going forward. Whether we tell it in Parliament or when we publish our results, it's those stories. But those stories cannot be told in black and white. It has to be a person's life that has been impacted in a positive manner. And certainly I look forward to learning and actually making a contribution towards that.
Yep, very powerful. I'm afraid that we ran out of time. I'm not sure if the program director can indulge us with just a response, and then we should be able to close. Yep. So then let's get your response from that, and then of course, Dr. Roro, one closing remark from your side as well.
Yeah, just so our science and technology park is built on the triple helix model. So it's public, private, and academia. So we've got signed agreements with Walter Sisulu University and Fort Hare University, and we try and create that platform to connect academia with the challenges that our tenants face. And when they have got an innovation challenge, we take it to our science park and try and involve academia. We've got a 3D design center that can be utilized. We've got Cisco's Edge Center, so for an SMME with an idea, it's a free service that we offer. Unfortunately, Fort Hare is more interested at the moment in burning down the building that they are supposed to be studying in. So the students last week embarked on that process. But it's also, you know, so I think the IDZ can only take it that far, and we've got the platform and the facilities to be utilized by students. We maybe just need stronger leadership to make everyone aware that that opportunity exists and tie in these solutions that are coming from academic institutions, because our goal is to innovate something in our science park, and then we want you to jump out into, we've actually got mini factory units, so you can start up as a small SMME producing a good or a service, and after 5 years you get promoted out of that manufacturing incubator into a fully fledged company. So we're trying to grow our own innovators, and it's a brilliant opportunity for academia to take advantage of. They must just do that.
Thanks, Chris. Thank you, Thabo. I think the G20 Sustainable Industrialization Hub work stream is a new model for international industrial cooperation, one that links clean energy, sustainable production, and inclusive development. I think for South Africa, this boasts strategic and practical opportunity to lead, to learn, and localize. Going forward, our focus should be on building readiness. Thank you.
Thank you very much. A round of applause for our panelists. All right, thank you. Back to you, Program Director.
And I think another round of applause for facilitator. Thank you, Thabo. Okay. It's been a long session. It's been over 2 hours. You've all been sitting here, and it's getting warm. So if you could just focus for 1 more minute. I'm just going to tell you what's going to happen so that everybody knows where they should be in 20 minutes' time. So we're going to break now for tea. The CSIR ICC team has put on their normal fabulous spread. You don't come here if you're on a diet, or if you do, you put it on hold for the day. We are a resource efficiency program, so we don't want to see any food waste. Enjoy those. Then we will be splitting into 2 groups. If you are more interested in the energy solutions, the technical talks, the infrastructure, when I talk about infrastructure, I mean not just the physical infrastructure, the digital platforms, the integration of all of these smart solutions, your place should be here in the Ruby Auditorium. We will be hearing from CSIR researchers as well as a researcher at the University of the Free State in the next session around planning and mapping and all those smart things. And if you are, like our sister over there, very passionate about the broader impact of what we're doing, particularly around SMMEs, community engagement, your place should be down the passage in the Emerald Room. We will start at 11:10, and that, please be seated by then. That will allow your room host to get the room settled and to kick off and allow the sessions an hour, because those will be quite short. We realized this was really long, so we made the next session quite short. So it's going to be an hour or so, and then we'll break for lunch. Lunch was going to be on the deck. So what I'll do is I will find out where it is going to be now, due to the weather, and we will communicate that to you in each room. So 11, if we could be seated in one of the two venues, ready to kick off session 2. Thank you, everyone. You've been a great audience.
Engineering. He obtained this qualification from the University of Pretoria. He also holds a MSc in Mechanical Engineering from the Northwest University and a BCom degree from the University of South Africa. Jan, over to you.
Thank you very much, Lindelani. Okay, as you've heard and as you can see, I'll be talking a bit on integrated solutions and specifically energy master planning. Now, as you know, I'm with CSIR, and you've heard a lot about CSIR today, but CSIR has basically been mandated to conduct research in the national interest, and in doing that, they collaborate with the private and public sectors, and the ultimate aim of that is to improve the quality of life of each South African. So when they spoke this morning about the communities around the industrial spaces and how the activities within affects them, this is also pretty much in the playing field of the CSIR, because our technology should eventually reach everyone. Now, if you go to the website of CSIR, you'll find on the landing page these 3 by 3, which is actually 9 different clusters, what we call them, and grouped into 3 divisions. And as you can see, there's quite a bit of different activities. There's even defense, there's mining, there's manufacturing, chemicals, and we in the Energy Centre sit over here in the Smart Places cluster. And the Energy Centre itself is divided into 4 parts. We've got energy supply and demand, where we look at technologies such as wind, solar, hydrogen, and one of my colleagues will be talking to you a bit later on our hydrogen activities, but also things like thermal energy, waste heat, and the use of that in the industrial processes. We also have a group that looks at batteries, battery technology, materials around that, manufacturing processes, reducing costs, extending the life, and so on. And then the third group is the energy systems group, where they do energy modeling using various tools. There are commercial codes like Plexos and Homer that are used, and we can do these sort of analyses on a large scale, like, for example, assisting with the development of the integrated resource plan, as we have done in previous years, but we can also do it for municipalities, and then also smaller units like industrial spaces. And I'll be talking a little bit about an analysis that was done for NCPC-SA on some of the industrial spaces that we looked at. And then lastly, it's also an important aspect, looking at the just energy transition, the socio-economic analysis, techno-economical analysis, then bringing in, for example, the effect of activities on communities, not only immediately surrounding the industrial space, but also further afield. Okay, so let's get into the actual topic, which is talking about energy master plans as a concept. Now, there's a formal definition that you can read there in the first sentence, but I think ultimately the operative word there is in the second sentence, integrates, because integrates basically, in my mind, means bringing things together. And there's a lot of things that you need to bring together in your mind when you develop a strategy. In terms of just energy sources, we usually think of electricity, but there are things like the fuels that are used, even for transport, for the vehicles. There's the way in which you generate process heat. Is it paraffin? Is it maybe bio material? All those things come into play, and they should all be considered. And then obviously technologies, solar, wind, battery technology, even developing technologies like hydrogen, they all need to be considered. And then also, as a third component, the stakeholders, not only the tenants, the management of the park, the investors, the municipality, the communities surrounding and further afield, All of those things are important. So the next few slides will be more of really a reminder of all the different aspects that one needs to take into account. We won't be drilling down into the details, but I'll just give you a bit of an overview and give you some examples. So what would be the objectives of an energy master plan? Security and supply, obviously, of electricity primarily, but also other forms of energy. And one of the industrial parks that we visited, the person said that he was always struggling to get the tenants to respond to a request for meetings and such. But during the time of load shedding, if there's a meeting around load shedding, he had no problem, everybody was there. And that just emphasizes the importance of the security of supply. So that's a very important one. Then also, obviously, cost optimization. What's nice about developing your own supply of electricity, maybe through a PV plant or wind farm, is that you can, if your assumptions are correct, get a very accurate idea of what your cost will be for the long term, medium and long term, which is much better than you usually have when you are exposed to tariff changes and sudden changes in your environment. So cost optimization is something to look at. Sustainability, obviously, there's a lot been said about that today already, and some of your tenants might be under pressure from their parent companies in Europe or America to produce their product with a certain percentage of renewable energy. That in turn places pressure on the park, and that in turn needs to feed into your strategy in order to meet those needs. Scalability, what usually happens is there's a bit of a piecemeal development of activities in an industrial space, and then you have like 3 or 4 different companies all generating their own processes using various methods, and it would make much more sense to centralize that, have them all together in the same area, and then also allow for maybe future expansion where you get new tenants that you don't even know about yet that might also want to use that. So in your plan, you must already think of how you're going to grow and improve and serve a larger community of tenants. And then lastly, synergy. Obviously, if you bring all these things together, the sum of all the parts would be more than the individual components, and that's what we're trying to get at. Okay, so what is integrated energy master planning? I think I've already alluded to this. It's looking at the whole system as a system, not as individual tenants occupying the same space, and then all those forms of energy, not only electricity, but process heat, fuels, even fuels for the transport in the park can all play a role in that plan. And then, yeah, as you can see, I think those have been covered quite extensively already. I think you're all familiar with all those different aspects that would typically be part of your energy master plan. Maybe just the last point, that last sentence, talking about time, that's again maybe another concept of integrating. You're not only looking at here now, you're also bringing in next year and the medium and long term. And with a proper developed energy master plan, you can plan for a 30-year time horizon. For example, I'll be talking about this analysis we did, and in that we actually planned from 2020 up to 2050. So you can do that in your energy master plan. Okay, also industrial spaces operate in a regulatory environment, and you've heard about that as well today, but those are just some examples of what you would find, and there's many more. I have the integrated resource plan, and that was one that has now again come to the attention of everyone with the publication of the latest version yesterday. And there's some interesting changes to what was expected, making some people happy and some people upset. But as a person that's working in the wind area, I'm quite happy with the outcomes. It's quite a sizable plan for wind power expansion. Okay, and then, yeah, there's also beyond that, there's obviously within this geographical area where you are, there might be additional regulatory environments from the municipality or the province and so forth. So all of those need to factor into your plan. Yes, just some ideas of how you can look at your plan. You can also look at things you can do very quickly, sort of low-hanging fruit. And I think most of these have already been addressed with the rolling blackouts that we experienced, like pilot solar PV, battery systems, diesel backups. All of those things have been looked at quite extensively, but there are also other things like starting to think about your governance. How are you going to manage the park? What sort of things you need to put in place, and those can usually be done fairly quickly. One of our previous speakers spoke about a special purpose vehicle that they're busy developing, which is quite an involved thing to sort out once you've started with it and you realize all the implications. So it's better to start with those sort of things earlier. And I think it's here where the NCPC-SA team can also assist. There's lots of online tools available for various things, and they've got some expertise. So I do want to invite you to consider asking them for assistance in these activities. Then going on to the medium term, then it's almost a little bit more of the same. It's just expanding it a bit more, like having larger solar arrays, maybe branching into wind energy if you have the resources, and expanding on your battery storage capacity. And then you can start looking at exactly how to integrate things like waste heat. So those would be on the medium term. And then in the long term, then things can really get interesting. For example, you see there the introduction of green hydrogen and biogas and synthetic fuels. All of those things can really change the whole landscape of the industrial space. You'll hear more about the hydrogen initiatives from my colleague that will speak later. But when I was on a visit to one of these industrial spaces in East London, I saw a biogas facility, which is really impressive, where they make use of waste product to generate process heat from where they then generate steam. And it's really an impressive system. And there's lots of opportunities and possibilities around that. So if you're starting to look at the long term, you can start looking at these things, because those contracts typically run for 15 years, and then it'll probably be renewed. So again, you're in the multi-decade planning horizon. Okay, so I'm just going to go a little bit faster. Benefits, these benefits, as you can see there, they again now link into your original reasons for having an energy master plans, things like improved reliability of power supply, cost control, your sustainability in terms of going green and reducing your carbon footprint. And then obviously also important is if your industrial space is really at the forefront of all of these approaches, then you will become more attractive to your tenants and you will attract more tenants, and it's basically a positive feedback loop that you create. Right, and then those other ones I've also addressed. KPIs, this is maybe one that could be of interest to you because obviously you want to start at a point in time and you need to measure your progress. And these could be some of the things to consider. For example, you can figure out how much or what percentage of your park is currently using low carbon sources, and then maybe in 5 years or 10 years or every year, depending on how you decide to do it, you can monitor this and see if you are making progress. Another good one is also just to look at your general energy usage, either in kilowatt hour or in gigawatt or gigajoule per unit output. This could be interesting because something that's also interesting that we discussed is that because parks differ and there's new tenants come and old ones go, sometimes the amount of energy that you use isn't constant. So a better measure would be to calculate your energy usage per unit to see if you're progressing. And then third one, percentage of tenants connected to shared utilities or integrated services. Again, that idea comes to mind of having a steam generation facility and having all your tenants that use that process heat together, and then they start sharing that resource. Yes, and then also looking at waste heat, that might be linked to the previous one, where your one tenant is generating a lot of heat, other tenant can use it, and see how many of those sort of symbiotic arrangements one can achieve. Great. Now, getting a little bit more into the detail of doing an energy master plan, I must just mention this focuses on electricity, not incorporating the other forms of energy yet. We are potentially working on that, and we would like to expand our capabilities on that side. But for now, if you look at the Energy Master Plan, it sits over here. So it's just one step in a broader set of activities. The other steps is complying to regulatory compliance. Getting funding is step 3, and as you've heard, NCPC-SA can assist with that as well in terms of getting everything in order to have a bankable project. And then once all of that is in place, then obviously you'll be procuring all your equipment and installing it. And then step 5 is the last one where it's operating, and there's also a lot of operational support required in that process. But today we'll just be looking at that first one, the Energy Master Plan. Okay, so there's various types of software that you can use. There's commercial codes like Plexos and Homer that are quite expensive, but they're very capable. And then you've got open source codes like PipeSA, which is a Python version for power system analysis. And that's what we used here. And the advantage of that is, of course, it's free. It's open software, open source software. And that means that you can, as a park management, you can use that and you can play around with it. It doesn't really cost you any license fees. What typically goes into this system, or what the aim of it is, it's actually to minimize costs. So if you look at this graph over here, each point on this surface would represent a combination of different technologies and the cost associated with it. So you might use, let's say, a certain amount of solar and grid and diesel generation. You're sitting over there, and you're meeting the demand, but you're not doing it at the least cost. And what this mathematical model does, it runs an optimization engine that finds you the minimum. And it does that for every hour of every day of every year that you're modeling. And then it will tell you need this much of these resources in order to meet your demand at the least cost. The trick actually lies in the input you provide to it, which is that same old mantra of garbage in, garbage out. The better the quality of your inputs, the better the quality of your outputs. And yeah, I think you can read all of that yourself. Obviously, renewables play a role, storage. The demand is very important, and it's sometimes very difficult to find the demand profile. For example, one of the industrial spaces we looked at got to a single substation, and it feeds the industrial park, it feeds some of the residential areas, and it also feeds some of the commercial entities outside the park. So that becomes quite a challenge, and then you need to have some interventions to try and get accurate information. Okay, tariffs play an important role, and obviously technology costs, but what you get out of it is your energy mix, which is what you're looking for. You can get some idea of the operations, what the economics of the whole project will be, and a very important one as well would be the emissions. And this would typically be your output. So you can see you start with the so-called business as usual, where you just assume I'm doing no interventions, and I'm just reliant essentially on the grid. And then the solution to the analysis will tell you when to invest in what technology. They are all color-coded here. Yeah, so it would be typically things like storage, solar, wind, perhaps biogas, and so on. And depending on your specific inputs, then it will tell you how you need to invest and use it in order to get the least cost solution. This is just a different way of showing the same information, and you can see there's quite a significant reduction in grid electricity requirement and the associated carbon footprint. Now, what's interesting here is one would think that, especially if it's quite cheap, your renewable resources, you would think that the model will just choose that and forget about the grid entirely. But as anyone who has a system at home would know, you can do it, but it's very, very, very expensive. And this is a least cost model, so it will always be reliant on the grid. You can put a constraint in and force it not to use any grid electricity, but that will then not be your least cost solution. Okay, another thing that's quite important is you need to have your inputs correct. This, for example, just shows you how solar energy changes Those different columns in the different shades of yellow indicate different technologies, and then on the axis, the horizontal axis would be the different months of the year, and you can see the resource varies constantly, and that needs to go into your model. Same with wind, it depends on the characteristics of your wind turbine, the wind speed, and there are certain losses along the way, but ultimately you need an input like this for many of the inputs, and you can see there every hour is accounted for. And then, for example, in the case of wind, it will tell you what percentage of your total installed capacity is available at that point in time. So if it's 0.7, it's 70%, so maybe 70 megawatts out of a 100 megawatt plant. So that would be one of your inputs. Then, as I said, your load, which can vary quite a lot. It can change at certain times of the year. When it's December holidays, there will be maybe a lower load. You can get certain industries that are heavy industries, so they run 24 hours a day at full speed, so then you don't get this sort of profile. You get more of a flat profile with the implication in terms of your renewables and your storage, because usually the PV power coincides nicely with the activities in the light and medium industry, because it's during office hours that the sun shines. So your storage requirement is significantly less. So that's why all of these things are important, and the accuracy of your inputs really determine your output. And then also things like your electricity tariffs. That's an outdated version of the Megaflex tariffs, and you can see there are different rates for a Sunday and for Saturday, and in the week there are peak times and so on. And all those things, hour by hour, need to be put into the model to give you the best solution. And then getting to the outputs, that's sort of where you get some reward for all your hard work and getting all the inputs in. For example, that would be your business as usual in terms of electricity tariff. So that would typically be as the electricity will become more expensive in time. But then as you have different interventions, you can effectively reduce the tariff. Or you can keep on charging the tenants that same tariff, and then the saving you could maybe use as investment in further infrastructure. It depends on the choices of the park management. And then also an important one, this is your emissions, business as usual, and then the various interventions. And this typically would be of great interest to companies who have a requirement to reduce their carbon footprint. Okay, so those are just some of the outputs. And then my last slide is also something that comes out of the model. It can actually tell you when to invest in what. So this blue, for example, is a wind farm, so it will ask you to invest this quite a big amount initially, and it's got a certain lifetime, and if the lifetime is set at 20 years, then after 20 years you'll have to invest that amount again. But all of those costs are included in your economical analysis. And then in terms of the solar, which is yellow here, it allows more of a staged implementation. But again, if you were to put your whole solar plant in on day one, it's fine. The model will just not use the full capacity, because it will only use what it needs to use to have your result being the lowest cost option. Yeah, so those are some of the outputs. Yeah, that's the end of my presentation. I had to rush quite a bit, so I didn't go into too much depth, but I hope I've given you a bit of an overview of what's involved.
Thank you, Jan. I would like to request my speakers, when you guys are done with the presentation, if you can have a seat in front here. We will have a question and answer session once the presentations are done. We are not doing too bad when it comes to time. Jan and the Energy Centre have been very instrumental in working with the National Cleaner Production Centre of South Africa when it comes to developing these feasibility studies for all these new technologies. So, colleagues, we will have a question and answer session once we are done. So please hold on to your questions, your comments, and insights. I'm going to introduce my next speaker, who is Dr. No, it's not a Dr. Prof. Tom Okello. So, Prof is an environmental geographer and sustainability leader who works bridges science, policy, and practice. He is an associate professor of geography at the University of Free State, and he serves in advisory role in UNFCCC on climate governance and sustainable development. His research focuses on climate change adaptation, environmental management system, GIS, and circular economic transitions. Prof. Okello has supervised numerous PhD and master students across South Africa and published widely on sustainability, resilience, and green innovation. He is very passionate when it comes to mentoring, and he advocates for evidence-based policy, and he works to strengthen African leadership in a global climate and sustainability agenda. And beyond academia, he promotes community engagement and environmental stewardship as a pathway to inclusivity and sustainable industrial growth. Prof, over to you. Not a problem. Sure.
Yes, good afternoon. Is it afternoon yet? Oh, good morning. Good morning. Right. From the title, please don't worry so much about the technical, because when you hear GIS and leveraging all these things, people think he's going now to bore us with the technical bit of it. Well, what I'm trying to present to you is to tell you that we can tap into GIS and spatial science and make it work for us. And Oh, great. So that is the outline of my presentation. I will try to speak about why sustainable industries spaces matter, and then give you a bit on the spatial intelligence and how it delivers, how it can deliver for the industrial spaces. And I'll not finish by not talking about policy integration, the barriers that we may experience, and give some practical recommendations. And you've heard from my profile that I am evidence-based, meaning that most of the things I'm telling you is that it has been proven that it can work, but how can we bring it home to our own industrial space? Sorry, right. Okay, let me see. All right, I got it. So industrial spaces are important not only to you, the owners of the spaces, but these spaces, they support South Africa in resource efficiency, because strategically they have been placed in several district municipalities and whatsoever to ensure that resource utilization happens there. And for now, through the eco approach, we're seeing it as an opportunity for them to actually help in resource efficiency objectives that are being promoted, because we don't have so much of resources, and much that we have, it's running out very fast. So these industrial spaces, they're also important in the sense that they are places where we get to experience the real problems that we are facing, the energy shortages. Like you'd expect an industrial park to keep running 24/7 to sustain the productivity in the market, but it's the places where you can actually feel that they feel the energy shortages in terms of electricity, because they need a lot of energy to generate what is happening. And they're the people who have the voices, the people who have invested. So when they talk about the energy shortages they're having, it's not that, if you look at the rationality of the problem, it's not that they're the only one with the only problem, but it's because they have the voice to speak out. And then these guys in the industrial park, they use a lot of water. and they generate a lot of waste. Then the guys who are responsible for traffic jams, you see trucks, whatever happening across. So these industrial parks, they offer us an opportunity for us to rethink on how we can utilize the spaces that we have. And I know we have moved quickly from the linear economy. And when that was happening, we in the academia, I think we're not so much consulted, but we were told because we're in the environmental field, now we have moved to the circular way. We need you guys now to start teaching about this, because we want this as a reality in 2030. Well, that's why you find that I'm here, because I want to get to know and listen to you guys on what is happening and where are we taking us in the next space. So evidence-based means that you make decisions based out of what you have gathered directly, indirectly, or cumulatively, and make sense out of it. So if you undertake spatial diagnostics, it's supposed to actually be able to assist you to be able to see how resources are flowing from one place to the other. What is constraining the access to these resources? Or why is it what is it so easy for this kind of resources to be expropriated? And then from time immemorial, even our ancestors, they had their own means of assessment on where to locate any human activity. But now we have the ability through spatial science to be able to, with precision, to actually say, we can locate this service here, or we need to relocate it from where it is based on the results that we're getting out of it. So GIS and spatial intelligence can actually help you to assess, because there's a lot of connections that are happening, be they geographical connections, functional connections, and all of that. And with the spatial data, and also with the ongoing collection of this data, you're able to actually monitor what is happening. And much of the decisions and the discourse that happens about how we're going to share resources can be better attained when we know factually what is happening and what are we likely to cause with our actions or our inactions. I've got 3 case studies, and this is one case study from an industrial park. And remember, the discussion is on leveraging GIS in the industrial spaces. We speak of renewable energy, this solar energy, and GIS can actually be able to assist us in mapping, because much of the possible place where you can place your solar panels within an industrial park, because the assumption is that the space has already been utilized. So the only space that has not been utilized is the roof. So on the roofs, the assessment can be done. You don't have to send initially your crew to go up and do the actual measurements, but spatially and remotely, you can be able to actually do the measurements and be able to determine if there is any shading from cloud cover or whatsoever, and which direction the sites are facing with regard to the estimated electromagnetic radiation that you are targeting on. So GIS can do that for you, and you can be able to calculate this, and when you are thinking of investment, you actually know that so-and-so has this space, and all of us, we can pull together or can go along, and this is the place where to actually focus on. The assumption is that the industrial parks exist in symbiosis, and one of our speakers said that there is symbiotic relationship that happens. You know, in symbol definition, symbiosis is like I'm gaining from our relationship. It's not one-sided. So in this case, you'd find that within an industrial park, some of the products, inputs, the byproducts are inputs to another industries within the park. So it helps with the issue of waste management. And GIS can actually be helpful to assist us to map so that you know who is likely to utilize your waste. Because waste is now money, because you find people are actually looking for certain types of waste and recycle them in the spirit of the circular economy, because the realization is that we don't have much. And if in the spirit of sustainable development and sustainable industries, we've got also to think about our consumer behavior with respect to the future generations. So in this case, you can use GIS to map the material flows, and you can match tenants and tenants within the park. And also you can prioritize, if you're planning for the route system within the park, which route, which tracks should use for accessibility and all of that, so that you decongest the place and make the industrial park a place to go and see. Water is a big issue within the industrial parks, and one of the missed opportunities within the industrial parks is rainwater harvesting. We speak about South Africa being a water scarce economy, but what are we doing about the problem that we are having? We can think of harvesting water. And if also beyond industries, I see most of our homes in South Africa, we don't harvest rainwater. In fact, they have gutters, but the gutters are draining and the water is going away. I don't know if somebody advised us that this water needs to be available to keep the water cycle, the hydrological cycle happening. Because if you harvest it and hold it, then that water will not be available in the system. Well, that is also admissible. So in this case, GIS can help us to identify material sites and networks for rainwater harvesting, and then also for wastewater recovery, so that the wastewater that is run off within the park can actually be recycled and reused. So the outcome of this exercise is nodes for shared treatment and reuse, and also to help in cost-benefit analysis. So within the park, it requires serious decision makings, right from the park management to the industries that are there, and also with the regulation, the government, and all of that. So but you need information to make some sound decisions, and through GIS and remote sensing GIS, you can actually be able to provide candid decisions based on the available data. And some of the inputs is you get technical data, you get all kinds of data, even social data, you can actually get it, and it can be processed through GIS systems. And if you are able to use the technical because all these informations, how it's introduced into GIS is in different layers or in different files formats. And all of this can actually be integrated to give an overall picture. You know, normally, for instance, the simpler way of demonstrating how this works is, you see when you're seeing your, for those of you who used your Google, the tracker to bring you here to CSIR, all the different information here it put together to show you the exact map to CSIR was different layers that have been integrated in real time. Some the form-based information that has already been there and is being used and all that. So what is happening within the industrial parks now? It's a history that can be traced back if you utilize GIS well as far back as to when they were actually put in place, if that data exists. So you, in the spirit of decision making with the relationship to GIS is that historically you can map from where you've come to where you are, and to try and visualize how the future will be like if we continue the same way we are, or how some of our decisions are going actually to affect the future state of affairs. So you see, for instance, if you are a park manager within that industrial park, network information will be very critical for you to actually see how things, goods, and everything moves around your park. And the utilization of GIS is very critical. And you cannot only leave it, because remember, we're talking about a network where everybody's contribution is key. Now, individual farms can actually contribute to ensuring that the network system works for all of that. And you see, for instance, if it's only one company, one industry, one company within the park that invests in GIS, it becomes very costly. But if you pool resources, then you find this is a dream that can actually be realized. And yeah. So a lot is spoken about the issues that happen within the industrial parks. Some of them, we speak of them very passionately, but the truth is that most of the time we don't have the accurate information. So spatial data is very critical in the sense that you can, if you have the ability to interpret that data, then you can actually, when you're scoring, score closer to the solution that you decide to have. So it is, it can actually help when there is continuous monitoring and in all resources, because for instance, within the industrial park, we know that if they're involved in manufacturing, then you are likely the people who are contributing to gas emissions, carbon dioxide, whatsoever. So if there is actual monitoring of this information, then we can see that so-and-so is contributing more than the threshold that has been set up. And also with water reuse and all that, if there is active monitoring, then you'd find that at the end, we could actually say, we have attained or we are on the road to attaining our industrial park status. So how do we embed GIS in policy and finance instruments? We've got to think of actually investing in the initial infrastructure. But first of all, you need to blend it into the system. And working together, when I speak of procurement aggregation areas, within the industrial park, different players can actually work together to ensure that they have the right inputs. Because once you have the right infrastructure, then you're able to show, by evidence, to show that it's actually happening. We're getting the data and we're using it in making decisions, and we can start seeing that in places where, for instance, if we have used GIS to improve the supply chain system, then your consumers will not suffer more like they'll be confident to know that that industrial park, if you are requesting goods or services, you are able to get them in real time. And then also, we'll also benefit from what? From freely available data in open source data. There are barriers to this, because some of you already say, why would we worry about this? And will it not involve additional funding, significant funding, and all of those? So, of course, we have to appreciate the fact that we have data gaps, and some people are still not confident about the system. And we don't have the technical capability to ensure that the system works. And then when it comes to fundings, the funding system is not harmonized, but it's still fragmented, every industry working on its own together. But one good thing of it is that most district municipalities, they have the system in place. So if we can just work together with them to ensure that we also tap into the information that they have. So of course, we've got to mitigate for these barriers and uncertainties, and that's the beauty of us thinking on how we can utilize GIS in these spaces that we're working on. So normally a recommendation is for a 5-year plan, but recommendation is that you can try to embrace it in a 3-year plan, see if it works for you. And within that time, if it works for you or not, you would have learned some good lessons of which you can actually work on improving or getting a new system altogether. So in year 1, you'll need to do diagnostics, then making sure if it's you targeting renewable energy and you want to introduce solar energy to ensure you actually know how much of rooftop that you have. And then year 2, you continue with the implementation of the program. And then in the 3rd year, I think you'll have information whether you want actually to continue or not. I know in a rush way, I've tried to convince you that GIS makes industrial sustainability spatially actionable and finance ready facilitation. We need to do some piloting to ensure that works. And all this calls for partnerships between the parks themselves, the funders, I know they're here, and then also the GIS brokers. And look no further from academic institutions. I've heard about the collaborations being spoken about in piecemeal, but we need to establish concrete collaborations between ourselves, our academic institutions and the industry. Because normally, the industry only looking at the industry as a source of your labor. But you need skilled labor. But sometimes we find we don't have the actual resources to ensure that the labor that you'll be seeking in the future is skilled. So there's many ways that actually institutions can work together and collaborate to ensure that sustainable industrial parks is a reality. Because as we've said, in the spirit of resource efficiency and cleaner production, we also do not want to waste the resources that we have, because we'd find that things that could have been done together are done in piecemeal, and at the end of the day, you realize that I've just been duplicating what my other friend on the other side was doing. So thank you very much for giving me the opportunity to share this with you.
Okay, thank you, Prof, for that insightful presentation. Colleagues, the Prof did say he tried to convince you that you buy into his presentation. Let's see if you guys are convinced. I'm going to open this session for question and answers. If there are any comments, remarks from the audience. Can I have a mic, please? Oh, by all means, go ahead, sorry.
Can I go ahead?
Yes, please, if you can introduce yourself and the organization you're representing.
Yeah, I'm Francois Rozon. I work with the Center for Renewable and Sustainable Energy Studies at Stellenbosch University. My question is for Jan Hendricks. Thank you both actually for your presentations. But maybe from the perspective of the principals you've been in contact with, is there interest in green steam? Are you starting to see people looking at it seriously? And also along those lines, what about those mini district heating and cooling networks where people can share waste energy and beneficiate it?
Thank you. It is. Okay, thank you. Yes, so the green steam, I think there is interest. As I mentioned in my talk, I went to a facility which makes use of waste product to generate steam that's being used. It wasn't on the industrial site though, but it was one of the potential service providers where they set up the system for the client, and all that the client does is they buy the steam. And through that, then they recover their investment. And it's typically a 15-year project duration with the option then to extend. So I think it's definitely a possibility, because I know some of the other nearby industrial spaces do make use of steam, but they each have their own boilers. So it's one of those typical examples where things can be designed better if you have a strategy right at the start. But in practice, things don't always develop that way. But often these parks aren't fully occupied, so even if you're already in a situation where you don't have the ideal setup, you can always make it better in future. So I think it's still an option. And then the second one, I'm not too familiar with that concept. I think some of my colleagues might, so I'm not going to venture an answer on that one. But you're welcome to ask some of my colleagues. I think they'll be able to give you a good answer.
Thank you.
Any other takers? Yes, Doctor, go ahead.
First, I would like to appreciate and thank the speakers who were elaborating their talks, which I believe are informative to the audience at large. I will start with you, sir, asking as to maybe looking at the integrated solutions that you brought about, you talked about. I believe some solutions are sourced from different individuals from different backgrounds who have got different backgrounds. I want to find out if there has been any easy collaborations between, or do you envisage any easy collaboration between these different sources of knowledge from different people, as it were? Like your engineers, your urban planners, how can you bring them together, and policymakers for that matter, how can you bring them together to establish a long-term solution to our sustainable industrial spaces, as it were? And also I want to, because I don't want to speak again towards you, sir, I want to find out also if there are any challenges that you have observed, you can envisage or observe, is either envisaged or have observed already when using energy master plans. So we want to find out then how can we avoid any pitfalls or challenges that can be there if somebody, some industrial parks would like to engage or use the insights that you have shared today. So maybe you can advise on that, sir. Thank you.
Thank you. I think one aspect that's very important when you try and improve things, let's say in industrial space, is to make sure that you engage with all the stakeholders. So I think your first question actually alludes to that, and the current project that we are involved with at NCPC-SA actually started off by having a round of stakeholder engagements where we try and incorporate or invite as many people as we can, all the people that could potentially have an interest. What we did find is that it is sometimes difficult to get everyone around the table. So there's been less interest than we would have liked, but I think that would be the way to do it, and to have those stakeholder engagements right at the start, see what the real needs are, because I think especially researchers are usually keen to come up with a solution without necessarily listening to exactly what the problem is. So I would say that that would be one of the ways to make sure that we address all of those issues. And then in terms of the challenges with the energy master plans, I think the main one in my view would be the fact that when you do the master plan, which can have a 30-year time horizon, you make certain assumptions. But as time goes by, things change. So maybe the park all of a sudden realizes they've got additional surface to put solar panels in. Now, instead of the original 10 megawatts, it's maybe 30 megawatts. And then the plan can't really adjust. And that's one of the reasons why we decided to use open source software So there is the potential to set up the model and then to help the park management to, just by changing inputs, run the plan again and see the new outputs without necessarily having to become, energy modeling experts. So that's a concept that we are working on.
I don't know, I'm not sure whether it's slide 14 in your talk, when you spoke about the energy mix options. So the question I had there was on inputs to the model. In the graph you showed, there was more continuous, and mostly in real life situation, you find that the inputs are discrete, if I would put it that way, fewer than the continuous graph that you showed. Are you able to adapt that model to any industry, as it were?
I think it is fairly adaptable, yes. I think that continuous graph was probably more attempt by the person designing the graph to make it look, nicer.
Okay.
But the output are actually more like those bar graphs that you saw. And the way the model works, it takes a so-called myopic view, so it will optimize for this year without any regard of what's happening next year. And then next year it will take that year with the input or the situation there. For example, let's say there's additional solar power capacity coming online next year, then it will use that. But it won't know beforehand that it will come online, because if you do the optimization process that way, then you get a different result. And we feel that this myopic method is better because it's more realistic, because we don't know the future. So we also tend to behave that way. We look at what the situation is now, make the best choice, and then next year we do the same. So it is actually more of a bar graph output than a continuous one.
Okay, thank you. And my last question will come to him.
If you can wrap up, please.
Thank you so much for your talk, sir. I think it interests me so much, especially on the side of GIS. It enables one to assess the site remotely, and provides ample information, as it were. So my question then comes on the assessment of the site, like visually or also. It's more like a heat map kind of thing that you will see on the picture, especially the first industrial park picture that you showed. And the inputs of that graph actually can be taken from the orientation of different buildings, as it were. But now the question I wanted to ask as to whether you're able to consider things like tilt angles within that, as it were. Can your model or can GIS be able to pick up the tilt angles of different roofs and so forth? And can you also input some structural integrities of different buildings that the park has at a particular point? Can you maybe elaborate? And how can we include such layer? For example, if we have to have an additional input rather than visually, how can we incorporate some actual data now?
I'm switching off your mic.
Sorry. Over to you, sir.
Thank you very much. That's a very interesting question. Well, in my presentation, I blinded myself off from speaking about those things, but also in relation to the previous question that you asked my colleague here on when you are developing an energy master plan and an integrated solution, because if you're modeling for such to happen, you build an open-ended model of which you can add in as many variables as much as possible, but dependent on the situation of the park. Now, because some parks have been situated in the valleys, of which receive minimum radiation, and if you're talking about maximum solar radiation in any given day, then you'd find that those aspects have to be put in place, because how the different industries were being located in the park, in the sense they did not put in in perspective, the issue of solar, they were interested, and they knew that the source of their energy would be from ESCOM. So now here we are trying to use the resources, the infrastructure that is there, to see if we can bring in solar energy. And then all those factors will have to be put in place, because you'd find that some of the decisions will even not, if they're actually well thought out decisions, they will be like, this is not a feasible place to invest in solar energy. You could rather invest in wind, because there's wind episodes happening around that time, around that place. So it's actually a consultative process of which it requires all these integrated piecemeal decisions to be put together for us to have a master plan. But the bit that we should not shy away from is to pilot. Let it try and see if it's working or not, and then improve on that. Thank you.
Thank you, Prof. I'm standing now between your lunch guys, but I see there are about 3 hands that I'm willing to take. Mr. Nuarinda, you will be second, sir, and you will be last.
Thank you so much. Mine is for the Prof. It is about affordability and skills transfer. If you are to apply, if you are to get an opportunity and apply your GIS in any of the industrial parks to do modeling, how affordable is it for the industrial parks to afford the software and all that stuff? And how is it easy for the skills to be left behind with the park management team, well knowing that it could not be, I mean, the guys you are working with could not be with a GIS background? Thank you.
Can I also take you, if you can introduce yourself and the organization you're representing?
My name is Azwi Mamanyoha from ESCOM, a wonderful company that is making profit.
Yeah, we know about that one.
You know. Yeah, my question is for Prof. Our department is called New Business Engineering, Innovation and Localization, and it ties very well with the theme of this conference. I was just interested in what Prof was presenting with regard to the models that they use. I wanted to find out if ever they've done any project that modeled the rooftop, maybe of Free State Township or Free State Suburb, and if so, do they have the results? And we just want to see whether it's working well, because we do have a challenge of modeling especially high density areas where there is a lot of consumption, both legal and illegal. Thank you.
Can I also take the lady?
Thank you so much. Karen Surridge from Sanedi. I work with our colleague who was on the first panel this morning. So this is a question for Jan Hendrik around the energy master plans. So the modeling around electricity is what you said was done. But considering something like the first fuel, energy efficiency, if one were to introduce parameters around that, as well as around heat, you can convert energy thermal to energy electrical. Can that be included in the model? And the reason that I'm asking is Dr. Francois' question triggered my mind when he mentioned the green hydrogen and so forth, is that if you are buying green steam or buying green fuel, you're getting that from an energy service company. Do you think the parameters of your modeling could be tweaked to incorporate all of those things? Because at the moment, it's not really an energy master plan, it's an electrical master plan. And heat is one of your biggest consumers. So anything that requires heat to produce something, whether it's the hydrogen or whether it's an actual product from the process, could have an impact there and could be useful in the modeling. But I just want to understand if it's possible to incorporate it that way. Thanks.
Jan?
Thank you for that question. Yeah, I think that's an important question. So I think the answer is yes and no. Yes, in the sense that there are codes, commercial codes, that can incorporate that, like Plexos and there are others. But they are generally very expensive. You know, you're looking at many hundreds of thousands of rand for a license for a year. The software we used is PipeSci, which is open source. And we had to do a little bit of development around that, so we only focused on the electrical side of it. But it is definitely something we can look at, and something that would be interesting to include. I haven't attempted that yet, so I can't tell you for 100% certainty that it can accommodate process heat in the system, but I believe it should be able to. But at the moment, the work we've done and that I've presented doesn't include process heat or anything other than electricity.
Prof, there was a question from that company that makes profit from Eskom.
Yeah, actually, I noted two questions, and I'll start with Dr. Nwarinda's question on the issue of affordability. Well, affordability, I would imagine, we're talking about industries that are making money. And if they're interested in profit making, then they should invest in proper infrastructure, and GIS is one of them. But so the level of affordability, I don't see it as a problem. If there is any struggling industry within it, there's the issue of working together and sharing the available resources. So I would imagine that they can work together that, and then also they can partner up with the academic institutions and even the local municipality to get the infrastructure in place and accessibility. And then for skills retention, I think we need to train, at least have a dedicated data system in the industry, that in the park and in the industry, that it's dedicated towards information capturing and monitoring and all of that. So with that way, you would actually see that it's not one person's responsibility, it's everybody's involved. And then if we have opportunities to have in-service, like internships for GIS guys to come in on the ground, then that will go a long way. And it's not only, it should also be, to enable this to happen, is that we should know that by default, all of us, we have had access to GIS resources. So it's just a matter of us making it work. Well, Eskom, I know everybody talks about you, and when the load shedding, when the load goes, when you have shedded off the load, people, they look at Eskom they blame Eskom for taking away the electricity, but they only remember Eskom when that is happening. And one of the big challenges I see as a scientist that Eskom has done to itself is to position itself as the only main supplier of electricity that will service everybody's needs. But what I've seen is that, needs required with relation to energy. Everybody in South Africa depends on, most of the people, they depend on electricity. But if we would have some alternative energy sources that we all think beyond Eskom, that, okay, instead of us cooking every day with electricity, we can have gas cylinders, or we can have solar and all of that. And Eskom can take a lead in that, propose innovation ways on alternative sources of energy. And then also should be accompanied by behavior change campaigns to tell people that when there is no Eskom, you can still survive, you can still utilize other forms of energy. Like you see, for instance, we are here at National Cleaner Production Center. We expect that Eskom will continue supplying electricity for us to enjoy the presence here. But when you look here, there's so much of lightning that is happening. And I think those NCPC, like cleaner production experts, they'll tell us that we have more light than we require here, and we're putting Eskom on pressure to ensure that the lights are on. But you see, for instance, if we only have enough light for what we need here, then the load on Eskom will be lessened, and then they will channel their electricity somewhere else. So your question on whether we have an actual example to give and we have data, well, I would say yes and no. Well, at the University of the Free State, some of the buildings have actually been turned into solar, there are solar roofs, and we're hoping that the data that it's able to generate themselves. I have been to a farm where actually I saw a farmer who has solar generator and ESCOM, but he actually supplies ESCOM the excess units that he's generating when the sun is so nice. Yes, there was a question there.
Thank you very much, colleagues. We are way beyond time. In a sentence.
Thank you, Jan Hendrik and Prof. Tom. Mine is not a question, just a comment to maybe inspire something for the future, so it won't take a moment. But as Karen was talking, something that stood out to me is the industrial energy use of our industry in South Africa is predominantly in the form of heat for their processes, steam generated from coal, HFO, etc. And their electrical use, while significant, actually pales by comparison to their thermal use. Now, what's interesting about thermal energy is electricity, when used, it's gone. But thermal energy, when used, there's usually a form of waste energy afterwards. So perhaps a client is generating superheated steam and running a turbine, and then they've got saturated steam at the back end that they have no use for. Or they're generating saturated steam at 10 bar, 183 degrees centigrade, using it in their process, and then they've got condensate return in liquid form at 90 degrees centigrade that they have no use for. Now, it was 25 years ago that I studied at university, but I remember a course called HENS, Heat Exchanger Network Systems, where within a facility like Sasol, you would take waste heat from one part of the plant, use it over here, where it could be the main source, then the waste source from over there you would use over here, and so you would distribute energy across your whole plant, and there were very complex mathematical models built around that. What I would maybe encourage you guys to begin thinking of is in an industrial space where you've got multiple users, you can begin to employ that kind of heat exchanger network system philosophy across the whole park. So you might have a bakery taking burning coal and generating steam over here and then generating condensate return. And that condensate return could be the neighboring fruit juice factory's primary energy source instead of being waste heat. And so you could begin to link up a whole park and drive energy efficiency and seek decarbonization through sharing of energy and energy efficiency, as opposed to merely addressing the source and saying, well, we're not going to burn coal, we're going to burn biomass. Well, that's great, but we don't have enough biomass in the country even to meet this little business park's needs. So perhaps that kind of sharing philosophy and applying your GIS principles to a park and knowing that heat energy can be redistributed where electrical energy is consumed and is then gone was just an idea I had on the back of Karen's comment. Thank you.
Thank you very much for that comment. I think essentially you are referring to or talking to industrial symbiosis. Colleagues, I'm tempted to wrap the session. Thank you for being part of this insightful session. I am told that the lunch is upstairs at Onyx. Thank you very much for your presence. Thanks. Jan? Thank you, Thank you very much.
Just to introduce myself, I'm Kanye Kagwe. I'm a project manager at NCPC-SA. And today, I'll be your hostess. So anything you need, just shout. Oh, whiskey. On the rocks. Okay, coming up right now. Okay. So we're about to put the speaker here, and we should get Okay, I think he's still on his way. So let's give him 2 more minutes. It's going to be worth it. Thank you, colleagues. Thomas Ross is first. There has been a change of program. I need to log in. Oh, there he is. The man of the moment just walked in. Apologies for that, colleagues. Thank you so much once again. Okay. Thank you so much, colleagues, for that, for waiting for Mr. Thomas. Hopefully the presentation will be worth the while. My name is Kanyisile Kagwe. I'm one of the project managers for the National Tuna Production Centre. My portfolio is in CSIR. So before he starts with his presentation, I'll just want to warmly welcome him and then give a short bio of who the man of the moment will be. His name is Thomas Ross. He's a principal research engineer at the CSIR in the Energy Centre located at the Smart Cluster. He holds a master's in mechanical engineering from the University of Stellenbosch. His 30 years of research career at CSIR has been predominantly in the field of thermodynamics, heat transfer, turbomachinery, and energy. His main professional interest is in the economics of the production of green hydrogen and derives derivatives in South Africa and the benefits this presents to the country. He has published and presented on this topic and is involved in several projects developing the evidence of base for the green hydrogen. Let's warmly welcome Mr. Thomas. Thank you.
Fantastic. Thank you very much. Good afternoon. I hope we're going to have some fun today. There's various issues that we want to get through. Hopefully there'll be some good linkages with myself and Corin, who will follow up after me. The brief given to me was hydrogen in industrial spaces. So I have a series of assumptions for this talk. Apologies if those assumptions are wrong. My assumptions are that the audience members are primarily either from industrial development zones or special economic zones, looking at how the various interventions can be made to attract investment in your particular spaces, or alternatively from national, provincial, and local government to try and understand where does hydrogen fit in here. I'm anticipating possibly that you have 3 possible reasons for being here. 3 sets of questions that you're looking at. You may know nothing about green hydrogen and want to know what all the fuss is about. You may hope to include green hydrogen in your business plans, and therefore you're hoping for some secret sauce. We will see whether we get there. And some may have heard some bad news and are looking forward to taking me apart after my presentation. Let us see how that proceeds. Let's begin with what is green hydrogen, just to make sure we're on the same page. Green hydrogen is essentially renewable energy stored in chemical form. We have renewable electricity from solar, wind, other sources, use that to split water into its component atoms, hydrogen and oxygen. That hydrogen is then a chemical with a very powerful capability of regeneration into other energy. You can use it in a number of different ways, as shown in this diagram, ruthlessly stolen from the Hydrogen Society Roadmap. And you'll see on the left, renewable electricity being used to split water. And there are 3 main pathways. You can use it as is, right at the top, for various purposes. You can react it with nitrogen at the very bottom to make ammonia. Ammonia is a widely used chemical product. Or you could combine it with carbon dioxide, and that's everything else in between. We'll explore some of those, but this is not meant to be a chemical lecture. It's meant to be really understanding economic opportunities, obstacles, and challenges, and how we navigate those. Why is green hydrogen a thing? Most of my presentations have at least this slide in it to make sure we understand the why before we get into the what and the how. If the why is missing, then we're barking up the wrong tree. There is strong climate regulatory and financing pressure, and it focuses on South Africa in 3 broad domains. The first domain really is global, essentially deriving from the Paris Agreement. South Africa is a signatory to the Paris Accord. As a result of the Paris Agreement, there's been a fair amount of finance activism, which puts pressure on disinvestment from fossil industries, particularly coal. You could argue that is starting to move back now. And there are 2 IMO organizations, the International Maritime Organization, the International Civil Aviation Organization, each of which have an international reach and regulatory environment seeking to decarbonize. So there's that particular pressure. There's continental pressure from the European Union. The European Union adopted the European Green Deal in 2020, and that committed the continent to a net zero goal by 2050. Obviously, if your entire economy is subjected to that policy environment, you try and protect your economy by making sure that any imports that are not made according to the same rules then face a carbon tax, and that's what the Carbon Border Adjustment Mechanism is, the CBAM. At the moment, that attracts import tariffs to 6 import categories if they are made without the same climate regime of what the equivalent product would have been made in Europe. Lastly, South Africa itself. We have committed, as a result of the Just Energy Transition Partnership from the COP in Glasgow, and as a result of this, South Africa will attract 8.5 billion in finance dollars, and 5 sets of donors, the European Union, the US, Germany, France, and the UK. The US, under the current administration, has rather publicly backed from that, which hence I've crossed it out in my slide. And the deal is we get the money if we move forward on 3 fronts: broad decarbonization and introduction of renewables, introduction of electric vehicles on broader adoption, and lastly, green hydrogen. So you can see green hydrogen plays a role in all 3. The second reason, apart from the climate pressure and the regulatory environment, is the economics of renewable electricity. This would simply not be possible if renewable electricity had the same costs that we saw in the 70s and 80s. It just wouldn't be attractive. Now, since about 2014, the declining costs have crossed a threshold, which means that renewable electricity is now cost competitive with the incumbent technologies, particularly in areas where we've got good solar and wind resource, and it's getting just better and better. So solar is now your cheapest energy source, as long as you have got a reasonable solar resource. Now, my third point here is that renewable electricity has limits. Renewable electricity is your go-to for decarbonization. It's your lowest cost, it's your most efficient, you've got fewer amounts of intervening events, but there are certain market sectors where direct electrification is either very difficult or simply impossible. And for that, you will need green hydrogen. Having said that, there is a caveat that comes. Green hydrogen is at best a second-class solution. And I say that as someone who is pro-green hydrogen, because I don't want you to get the wrong idea. It's not a silver bullet. It's not going to tick all your boxes. But there are certain boxes that you can't tick otherwise. So I've mentioned that electrification with renewable electricity is always your go-to. And the reason really is given in this diagram that you see here on the left. If you have the same amount of renewable electricity installed, if you just use the electricity in mobility, for example, if you just use that electricity in an electric vehicle with internal batteries, about 70% of it reaches the wheels. If you convert it to green hydrogen first, by transmission and electrolysis, compression, use in a fuel cell, then roughly 1/3 of this reaches the wheels. If, on the other hand, you take this hydrogen and you convert it via a Fischer-Tropsch process or something other into a liquid fuel and then burn it in an internal combustion engine, that value is even half this value. So you can see this is not what you would choose given options. But sometimes you don't have options. If you have range anxiety and you need to go a very long distance, then battery operations may not be in your operational possibility. And in at least 2 areas, which I will come to, there are significant reasons why you would use green hydrogen. Firstly, in regions, geographic regions, where your renewable electricity is constrained. That means you have to import all your energy anyway. So you may as well import it green in the beginning, and that's what Japan is doing. Secondly, in your hard-to-abate sectors, heavy-duty, long-distance transport, that typically falls in 3 broad categories. Rail is a special case. I will explain it to anybody who wants to chat afterwards, because otherwise I can get carried away, anyone who knows me, so therefore I want to try and stay on message here. But aviation and shipping, particularly difficult. You don't really have options. You need chemical liquid fuel enabled to get 12,000 kilometers with heavy cargo. In industry, there are a certain amount of chemical processes, typically reducing chemical processes. We have to steal oxygen from some process. Iron for steel making, you've got to steal the oxygen from iron oxide in order to leave behind raw iron for steel making. Manufacturing of ammonia is classically done with fossil fuels. But ammonia is critical for food security, for a number of chemical processes, and so on. So in these areas, you want to be looking at green hydrogen. If we focus just for a moment on aviation and maritime shipping, you're looking at alternative fuels. And your go-to for alternative fuels is always biofuels. Biofuels are going to be cheaper, slightly less complicated, don't need significant infrastructure. But nature has not been kind to the globe with respect to biofuels. You cannot do it everywhere. It's imperfectly distributed around the globe. And even those areas where biomass is available, you must still apply sustainability practices. Otherwise, you're going to have indirect land use change or direct land use change, a whole sort of undesirable consequences. And significant parts of Africa, you simply don't have the biomass. You're water stressed, you don't have the arable land, you don't have the rainfall, you don't have the soils. In those areas, e-fuels look like your only remaining option. Now, as you can see in this a diagram here, it gives you an idea of the cost at which we can produce hydrogen around the world on more or less the same assumptions. And what we are looking at here is essentially, it's an analog for your solar and wind resource together. Because the electrolyzer is an expensive piece of kit. To make cheap hydrogen or lower cost hydrogen than other places, it must run for as many hours of the year as it can. And for that, you need solar and wind together, and that gives you an idea of areas where that is the case. So there are 4 fuels of interest. Ammonia, you only need nitrogen from atmosphere, which means you can make it anywhere, because you capture nitrogen from atmosphere. Ammonia, you use in maritime shipping, in vessels, either new or that have undergone a retrofit for their engines. You can't use it in a classic engine. Typically, you would have diesel as your pilot fuel that gives you your spark, and then your ammonia does the heavy lifting. Ammonia is also very necessary for fertilizer, so you have this other side product that you can have. Methanol. Similar to ammonia, you need carbon now instead of nitrogen. You also need retrofit vessels in a similar manner. Methanol is also a very useful intermediate chemical. Practically anything that you can get out of a refinery, you can make from methanol. So as long as you've got green methanol, you've got a good pathway to green chemicals. As of now, there are 64, wait, let me get this right. These numbers are wrong, apologies. There are 60 methanol vessels in operation and 340 on order, and there are 5 ammonia vessels and 64 on order. That's what comes of editing your slides just before you present. Apologies. Fischer-Tropsch, finally, the way of making e-kerosene and e-diesel. Fischer-Tropsch has the benefit of the fuels being drop-in. You don't need a special engine. You don't need special modifications. You can blend it with a fossil fuel to reduce the costs. There are a whole bunch of possibilities. E-kerosene you use for aviation, e-diesel you use for shipping, and you co-produce e-kerosene and e-diesel at the same time. As much effort as you put into your catalyst to try and tune it to the one way or the other, you just produce slightly more of the one than the other, but you're always going to produce both. So you want to be able to sell both, because that means you are able to recoup the green premium in both, which means that the green premium individually is not that high. Also going to need green fuels whenever you use ammonia and methanol anyway, because you need a pilot fuel. And that's going to give you a spark, and you're going to want that to be green as well. This gives you an idea of major shipping routes around the world and some of the pinch points where you see those shipping routes. The colors show you the type of vessels. So a light blue is going to be container vessels, typically going through the Suez Canal. Dry bulk, you see a lot of that going around the Cape, and a fair amount of tanker traffic as well. The circles show you interesting ports around the world and bunkering hubs. It gives you an idea of where things are possible. The fact that we don't necessarily see a bunkering hub at our favorite port doesn't mean there's anything intrinsically wrong with the port. It just means that more infrastructure needs to be invested. Looking at Fischer-Tropsch, these are the Fischer-Tropsch facilities around the world. And as you can see, South Africa pretty much corners the market on this particular route. This operation that you see here in Brazil is very small. It's in the order of a pilot plant. It's about 20 barrels per day, as opposed to 45,000 barrels per day for Petro-SA and 160,000 barrels per day for Sasol. So this gives us a particular advantage which could be exploited. This slide shows you where green shipping corridors are being planned around the world. There are a number of them. One of interest is one from Saldanha Bay. It's an iron ore corridor, currently under negotiation. That's all the good news. You have the bad news that I'm sure some of you already know about. You'll see an interesting contrast between the top row and the bottom row. The top row is positive. You'll see the amount of electrolyzer manufacturing capacity has been growing consistently. This is good. However, the planned electrolyzer manufacturing capacity, significantly larger but very small amounts, are reaching financial close. The amount of installed capacity, electrolyzers actually running, that is growing. This is a huge leap, and 9 times since 2021. That's non-negotiable. It's clear. This is a good trend. However, the announced electrolyzer projects dwarf these numbers, with very small numbers reaching final investment decision. And lastly, the amount of hydrogen actually produced, predominantly from carbon capture, and a small amount from electrolyzer. It is growing. It is growing. But again, it's dwarfed by the announced projects with small amounts reaching final investment decision. What does this mean? Here we can see comparison of electrolysis hydrogen projects and fossil with CCUS around the world, announced projects for 2030, with varying degrees of certainty of reaching final direct operation. Here, in terms of how much we can have faith in that announcement, where is produced around the world, and the various different stages. You can see a degree about how much it's delayed. A lot of electrolysis projects delaying. We are seeing that if you add all these together, that low emissions hydrogen could reach 37 megatons per annum. That's a really attractive number. But currently, only about 10 megatons per year will be almost certain or strong potential. In 2025, which is now, not 2030, only 4.2 megatons per year is operational. But that's it. That's five times what it was in 2024. So you've got good news and you've got bad news, and you're trying to ask yourself, what does this mean? Essentially, it comes down to a large degree about a challenge or a contrast between the developed world and the developing world, emerging markets and developing economies. You can see that from the announced projects, about 9% have committed investments globally, but only 0.5% in emerging markets and developing economies. Not a really good number. Only 5% of emerging markets have moderate potential to be operational by 2030. And in emerging markets, they're almost exclusively electrolysis-based, whereas around the world, there's a fair amount of carbon capture going on. So clearly, the emerging markets is where the sun and the wind is, and elsewhere is where the fossil assets are, where you can steal out the carbon in order to have those products. Now, here you can start seeing some hints. The emerging markets are heavily reliant on exports. You can see in your trade focus. And because they're heavily reliant on your exports, we also know that international demand at scale is yet to materialize. So the emerging markets are waiting for something to happen, waiting for a market to move, waiting for an international climate agreement to be finalized, waiting. This gives rise to frustration. We have financing challenges. Our cost of capital can reach 15% compared to 5 to 7 in advanced economies. And this particular opinion coming from the International Energy Agency, you can accept it, you can reject it, but it's there, essentially saying that the amount of penetration in renewables in emerging markets is quite small compared to other areas. And that then means that there is a perception that if you can't even move electrons, how can we trust you to move molecules? Whether that's a fair assumption, it is what it is. That's the backdrop. If we look at the largest possible market, which is maritime shipping, what would actually drive this to happen? I want to just sketch a pattern for you. That the IMO, it's an agency of the UN, 160 member states, South Africa is a member state, and has it committed to net zero, 2023, 2025, April this year, it agreed to the rules for essentially a globally binding carbon tax. And there are two components to it, a technical measure and an economic measure. The technical measure has a fuel standard dictating how much the fuel must decrease in greenhouse gas fuel intensity index. Essentially, how much embedded carbon, how much embedded fossil carbon is there in the fuel. There's a requirement that then decreases. And then the economic element is, if a vessel exceeds its allocation, it pays a tax. So if you exceed the emissions of the more stringent direct compliance, you pay $100 a ton of CO2 that you emit above your allocation. If, however, you can't even get the base target, you have an additional $380 a ton. This was all signed and good to go in April. This creates a market. And the idea was that in October, this would be adopted. That is last week. Unfortunately, this was torpedoed by the US and Saudi Arabia, if you have been following the news, with some very aggressive diplomacy, if you can call it that, threatening member states, threatening individual IMO individuals, a whole lot of rather unsavory things. So this is now delayed in terms of this market. But nonetheless, there are a number of shipping lines which have individual voluntary commitment to decarbonisation. They don't do this primarily just because they're great corporate citizens. They do this because a lot of their customers want to decarbonise operations. So they're looking after their bottom line, and there is some rationality and some sense in that. So this brings us to our final slide. What does this mean? And I think we can encapsulate it by saying green hydrogen is necessary to fully decarbonise. That is clear. But it's not yet commercially mature. If it was, we would buy it like we buy solar. That's also clear. So it's not cost competitive with fossil equivalents and will still need support. So there's an element of risk there. How do we manage that risk? We need to understand the business cases are difficult. You need to really look for the business cases which make sense. We have a number of hydrogen companies around the world that are facing bankruptcy. Maybe they approached business cases that they thought was a lot closer than it really is. But there are other projects which are still ongoing. So finally, nations, countries, governments need to choose no-regret trajectories. You do investments that you probably would have done anyway, and you look to see where that overlaps with the hydrogen demand. Don't go off on a tangent where you would like hydrogen to be, because you will then commit some funds and possibly find that you're throwing good money after bad and you don't have uptake. And then you're left with a stranded asset. Looking at potential no-regret trajectories, CBAM compliance. South Africa... Did you know roughly 66? I didn't, actually. South Africa must be compliant to CBAM, the Carbon Border Adjustment Mechanism. The EU is a fairly large market for us. And at least in our automotive sector, we know steel fits in there, and that's a problem. So we're going to at least need green steel. So we are not rushing off on a tangent to go and make green steel. It's looking after our own market share. If we don't do that, we're going to have pain. Green iron export may have opportunities. Saldanha, it's an existing iron ore port. It is our deepest deepwater port, and it's in a good renewable resource area. However, making green steel there doesn't make sense. We don't have scrap steel, and you need scrap steel to make steel from virgin iron. And if you're not prepared to pay the cost of transporting it with Transnet Rail, well, then maybe making steel isn't a good plan. But making green iron and exporting that is attractive, possibly because it relieves European steel makers from relying on scarce, expensive European Union green hydrogen, wheeled through expensive, complicated European electricity networks, attracting all their relevant tariffs. Made in South Africa, you can bypass that. Secondly, did I do something? Green hydrogen to export to Europe will be expensive for us, but we're exporting the iron ore anyway. So converting it to iron means that we reduce volume, we exporting to the European Union. We increase value, we exporting to the European Union. So we have beneficiation. And we get volume for Saldanha, which justifies the hydrogen investment. In the maritime market, ammonia and methanol, I mentioned. Ammonia has the benefit of being a fertilizer displacement. Methanol is an intermediate chemical, but you need a carbon supply. We have 2 Fischer-Tropsch facilities that can produce kerosene and maritime diesel. And here, we need to really support our Department of Transport in their negotiations at the IMO. While we struggle to export to the EU specifically sustainable aviation fuel due to complicated sustainability regulations in RED2 and RED3, IMO is still writing those regulations. So we need to be in those discussions while they're being written now, not 2 years from now when we get our act together, now. South Africa, we've got 70% of the world's chrome reserves, but China is the largest ferrochrome producer. Now, maybe we won't do classic ferrochrome, but we could do green ferrochrome. If you can use hydrogen to reduce iron ore, why can't you do the same for chrome ore? Which means we'll be able to provide chrome for European stainless steel producers and cut out the middleman. We have 80% of the world's manganese resources, and we produce 36% of the world's manganese. Both of these have pyrometallurgy to reduce. I leave that with you to think about. Happy to take any questions when it comes to question time. Thank you. Am I supposed to take questions? Right over there, sir.
So, taking into account your first slide, which is the driver for all of this, the reduction in carbon and the finance.
Sorry,
and
it's
all
gone.
of that. That's fine. And then comparing pure solar vehicles to hydrogen vehicles, etc., etc. In that whole equation and calculation, has anybody ever gone and done a full calculation of the full carbon footprint of all three? And the question I'm asking is, mining the minerals for the batteries, producing the batteries, reducing, well, still not really knowing what we're going to do with the batteries afterwards, and what the carbon impact of that is. Is that then still, I mean, I know that the amount of energy that actually goes into driving the wheel is more from solar and battery. But in terms of the actual impact and what is actually driving the move to a greener fuel, is batteries really a competitor? Or is the carbon footprint of producing those batteries maybe bigger than doing the hydrogen?
I'm tempted to think that the word you're looking for there, sir, is life cycle, the full life cycle assessment.
Yes.
So it's not just the carbon.
Yeah.
It is an argument often made against the battery industry and the impact that you have post-mining landscapes and all that. That is not my domain. I have colleagues for whose domain it is. But the argument, just sidestepping your question for a moment, is rather to say that it's a very strongly horses for courses argument. And the area in the world where hydrogen vehicles are doing the best is China, with significant volumes, particularly of heavy trucks. But even in China, the heavy trucks are hugely outnumbered on the battery side than on the hydrogen side. It really comes down to your overall techno-economics and what the customer is prepared to pay for. We may be able to prove that your life cycle assessment costs are higher for a battery, but the market has largely decided when it comes to e-mobility and terrestrial transport that they prefer batteries. So you have to find the business case where the hydrogen sort of makes sense. Now, you mentioned mining. Hydrogen could be attractive for mining because it enables you to decarbonize inside the fence, particularly if you do combustion. If you're going to do fuel cell vehicles, they're efficient, they do all sorts of lovely things, but, and I say this as gently as I can, this is Africa, it's a rough environment, things break. Also, wherever you are in the hydrogen value chain, the weakest point is often the refueling station, the high pressure compressor, that fails. And if there are two rules in mining, it is a mine operates 24/7 and safety is paramount. Anything which gets in the way of the mine operating 24/7 is not attractive. So if you use your hydrogen not in a fuel cell, where a fuel cell can only run on hydrogen, but you have it in an internal combustion engine where hydrogen is a decarbonizing element, that is a better business case, because when the hydrogen refueling station fails, and it will, you just keep running on diesel for that month, or 6 months, or however long it takes to get the technician from Germany to come and fix this thing. So you need to analyze fairly rigorously your business case where this sort of makes sense. You have the possibility of making your own hydrogen fuel, but then you need to have your own specialist people, which is not always what a mining company wants. If you're Anglo and you've got deep pockets, then that's a good way to go. Also, if you happen to have platinum in your portfolio and you want to push that. So it requires some fairly delicate analysis. But when it comes to full life cycle assessment, I suspect that a lot of the interest is academic rather than technical. Ultimately, people, I think, follow the rands and cents, unfortunately. It's not the answer I would have liked to have given, but it's the answer I can defend. Yes, ma'am.
There's a question online
Yes.
from Ronald. Hi, Thomas. What will be your response to views that green hydrogen requires excess renewable electricity and water resource that South Africa does not have? Second one, what are the pros and cons of hydrogen from waste in industrial spaces? And lastly, where will the CO2 for methanol or syngas come from?
Those are good questions.
Yeah,
I'm
those are
going
the
to answer the
questions.
first question, then I'm going to ask you the other questions again.
No problem.
Electricity and water. Those I can answer relatively easily. You need water to electrolyze to make hydrogen, obviously. South Africa is water stressed, equally obviously. So, if we are making hydrogen for export, we are doing that pretty close to a port, which means we're close to the ocean, and our go-to is desalination. Desalination is not an attractive water source for certain communities, particularly agriculture, because it makes the water so much more expensive than surface water. Hydrogen, however, is a very interesting business case. When you use desalination as your water source, it increases the cost of the hydrogen only in the order of 1%. The production of green hydrogen can be done anywhere from very good to very bad, between $2.5 to $6, $7 a kilogram. The desalination cost fraction of that kilogram of hydrogen is 2 US cents or less. So economically speaking, desalination costs are irrelevant. More than that, it's a bragging right for the hydrogen producer. If you're producing hydrogen on the South African coast, if you're doing it in Saldanha Bay, the Berg River catchment, it's a water-stressed area. If you're doing it close to Nelson Mandela area, where we have seasonal water stress, you can oversize your desalination plant. It's going to increase your hydrogen cost marginally. But you can brag you are contributing to water security, not detracting from it, particularly in water-stressed areas. Desalination built for water, for intermittent water stress, is the most difficult thing to finance. If you build a desalination plant in the Persian Gulf, easy. You know whatever water you make, someone's going to buy. If you build it in South Africa during a drought, everyone buys your water when it's drought. The second the rains open, the heavens open and the rain falls and the dams are full, then, no, I think I'll take the water from the dam, thanks very much. I'm not interested in your high price. How do you repay your loan? Makes a very, very difficult financing option. For the hydrogen producer, it's easy. He's doing it for a clean reason, so he's built the desalination plant. It's the best possible case. On the issue of renewables, do not make hydrogen with excess renewables. Bad idea. Make hydrogen with purpose-built renewable assets and sell the extra renewables into the grid. Far better option. We do not have problems with available land or renewable resources. And the cost of making hydrogen without selling the extra renewables to the grid in good areas in the order of about $3.5 US per kilogram. It's not a bad price. If you sell the extra electricity to the grid, that drops by in the order of 14%. It just helps your techno-economics. Makes it a bit more difficult for Eskom to wheel the electrons around, but let's confine ourselves to the problems that directly concern us. So the renewables and the water, that's the easiest question to answer. Remaining two, please, ma'am.
What are the pros and cons of hydrogen from waste in industrial spaces?
Hydrogen from waste in industrial spaces.
Yes.
I'm assuming by waste we're talking about municipal solid waste, biodigestion, that sort of thing? Anaerobic digestion? In that case, I would just stick with the biogas. Don't go and strip the hydrogen out. That biogas has value. And use the biogas as is. It is a good replacement for methane. Don't go to all the effort of cleaning that up and make it for hydrogen because your volumes aren't all that great. Use the biogas as is. That's what I'd say.
Okay.
Last question.
Last question. Where will the CO2 for the methanol come from?
That was an evil question. Carbon is a problem. Carbon is a problem because when you are making hydrocarbons, you want your carbon to do three things. It must be affordable, it must be available, and it must be sustainable. Solving all three at the same time is difficult everywhere in the world. You can do direct air capture, very sustainable. You can do that everywhere. It is the most expensive way of capturing CO2. So it's not going to happen anytime soon. You can take it from a coal-fired power station or an industrial point source. That's available in a number of places around the world. Everybody generates electricity. So it's available at scale, and it's at reasonable cost, in the order of $80 a kilogram. Unfortunately, the European, the EU RED2, RED3 doesn't like that particularly much, and they will only allow you to do that up to 2036. So if you're selling it to the EU, that's a problem. If you're selling it to the IMO, you're on a better wicket, because the IMO doesn't care where the carbon comes from. The IMO cares what is the embedded carbon in the fuel at a given year. So if you've done your life cycle assessment, you know what the carbon is, then you should be good to go. You can get CO2 from biogenic sources. You can get it from paper and pulp industry. You can get it from digestion processes, fermentation. Cheapest, order of $20 a kilogram. Unfortunately, that is not universally available. Paper and pulp, I think it's only South Africa and Swaziland that does that in Africa. And so therefore, meeting those three requirements is particularly difficult. And that's one of the reasons why there's pushback in Europe against the renewable fuel, I always get this wrong, renewable fuels of non-biological origin and the rules for hydrogen and the rules for carbon. I don't have a good answer for that. My particular preference is to get carbon where you can, do your fuel LCA assessment, get your embedded carbon, find that market that will accept that. The EU is sticky, but the EU is what, 14,000 kilometers away. The maritime market is at our coasts. So therefore, that would be a lot more attractive. Did I cover all the questions? Okay.
Yes.
Anybody? How are we for time? Are we good? Yes, sir.
Thanks, Thomas. I just wanted to ask, I mean, a lot of what we see in terms of the new hydrogen projects around the country is focused on export. But to what extent is this kind of developing a local market playing out?
Local market is very difficult for a number of reasons. The South African economy largely, and I say this as a mechanical engineer, not as an economist, so I'm happy to be interrupted by it. But the South African economy largely just tries to survive. And any additional regulatory demand is not well received. There's enough regulatory demand for various things. So to find that customer that's prepared to pay a green premium is a difficult challenge. I will give you two contrasting examples, the logistics sector and the mining sector. If you want to decarbonize logistics, you are an Imperial truck and you're moving product from Joburg to Durban, and you go towards a green hydrogen vehicle. Yes, your logistics becomes cheaper. Unfortunately, very few customers are prepared to pay for having their product move cheaper. They want the green, but they don't want to pay for the green. That is an ecosystem problem that I'm not sure we've fully addressed yet. So for the logistics sector, where your hydrogen truck is going to cost you 3 times what a regular truck costs, and your fuel is going to cost you twice that amount, the business case just simply isn't there. Unless you have a particular customer who's really keen on his green credentials. Contrast that with the mining industry. A certain part of the mining industry is under significant pressure to decarbonize. So the decarbonization pressure does not come from the South African state or from the South African regulatory environment. It comes from the customers overseas, and they want to go and see, in terms of your carbon reporting, in terms of everything else, how green are you? Otherwise, they will go somewhere else. So for the mining industry, and this is not all products, but it's a significant subset of products. They need to decarbonize irrespective of the local regulatory. It's a hygiene factor for them. If they don't do it, they don't survive. So now they look at, how do we reduce our embedded carbon in our products? Batteries are cheaper. Will batteries be able to do the round-trip, heavy, punishing duty in a mine? Do you need to go for overhead catenary lines? Would hydrogen give you better endurance compared to batteries? These are all the challenges that the mining industry is busy facing now. One area where things could make sense, remember I did say that hydrogen needs support. Sometimes hydrogen works best at pilot plant level, where you have got the political commitment of a political entity, let's say a metro or something, and you decide to decarbonize this bus route, it nowhere near makes economic sense. But you've demonstrated something, and you are able to support the extra costs for a political reason, because it's not yet an economic reason. You may do that because you want to demonstrate something. You want to do that because you have a number of requirements. If you do it purely economically, rather take the route of Golden Arrow buses in Cape Town that went electric, and they found that their energy costs have dropped 70%. Okay, the investment costs have gone up, but I mean, given that a bus works most of its life, that's not a difficult argument to make. So finding that particular business case where you can find someone who's prepared to pay the cost that is not going to unduly disrupt the business model can be challenging in South Africa. That's one of the reasons why the focus is on export. The beauty of maritime shipping is that the customer comes to you. So yes, your customer is external, but your point of supply is local. So you don't need to move it. And that's what makes it attractive. Yes, sir.
Yeah, greetings, Richard Shan from ESCOM. I'm more interested, we spoke to the Fisher Tropsch.
Yes.
Yeah, that one, but we didn't really put too much airtime into it. Like what it was mentioned, there are only 2 facilities currently in the country. What market is it looking at? Is it for domestic consumption? Then the other part, also here you only spoke to 2 sectors. You mentioned the maritime and aviation. The auto industry didn't come through there. Can you also
the what industry?
Auto.
Auto industry.
Automotive industry. If you can talk to that as well.
All right. Fisher Tropsch Industries. We have 2, Sasol, privately owned, Petro-SA, owned by the state. Sasol went a fair way on the green hydrogen journey. Got frustrated at its inability to make progress in offtake and difficulties with the European regulatory environment. They were involved in the Buchubai project. They had a memorandum of understanding with ArcelorMittal. They've walked back from that memorandum with ArcelorMittal, and it's not quite clear where they are with Buchubai. They will attend meetings on Buchubai, but they're no longer spending money on it. Buchubai is seen as a more long-term, whereas Saldanha and Kucha are more short-term. Contrast that with Petro-SA. Petro-SA is looking at hydrogen not because they're committed to green. Petro-SA is looking at hydrogen because they're in an existential crisis. Their natural gas supply has now petered out in the gas supply in the ocean. There have been numerous attempts to try and kickstart it from various different ways. There was the possibility of landing LNG. It's not an attractive coast. It's difficult to land product there. It's a good reason why there's a single buoy mooring and not a significantly upgraded port to be able to take vessels. So landing more natural gas from other sources will be difficult. Not impossible, but difficult. There were the fines, I think Brilpada and the other one off the coast. Total Energies decided to go somewhere else for various reasons, which I'm not going to get into because it's not in my wheelhouse. So what do? They've furloughed 600 workers or retrenched them or let them go, or whichever euphemism you choose, and they're running on care and maintenance at the moment. They take fossil product from somewhere, do some internal treatment, and then they sell that to Eskom, to you guys, to run in the peaking power plant. They exist only as a middleman. So therefore, they have some very deep questions to answer. So in their classic business model, it's not looking good. In a future business model, however, they are uniquely positioned. They are a Fisher Tropsch facility in a good renewable resource area on a major shipping route. So that means they are capable of making fuels other people can't make that can sell to far more vessels. You remember earlier in my slide, I said there are 60 methanol vessels. Well, I said it incorrectly, but there were 60 methanol vessels, 240 on order. There are 5 ammonia vessels, and there are maybe 60 on order. There are more than 100,000 vessels larger than 5,000 gross tonnage, the existing fleet. Your market is just so much bigger. And you'd have very little competition. You saw where all the other Fisher Tropsch facilities are. Your problem is where do you find the carbon? That is a problem. We are looking at various options of doing that. One very attractive possibility was suggested by the Chinese delegation to the International Maritime Organization meeting in October last year, where there'd been a lot of work done on carbon capture on board vessels. So carbon capture, like you would do at a coal-fired power station, you do it on the vessel, and the idea is that when you go into port, you discharge the CO2 at the port, and there it goes to sequestration. Now, I'm not quite sure where South Africa sits with the sequestration of CO2. My understanding is that the Council of Geoscience was doing some analyses. I further understand that we don't really have terribly great resources for discharging carbon. I'm happy to be corrected. It is not my primary domain. What the Chinese came up with, however, is saying, instead of discharging for sequestration, use that to go and make your marine fuel, because that's going to be used on board the vessel again. So if you just do it once, capture it once, turn it into fuel, burn it once, then the carbon load, if you like, of the original fossil is spread over 2 vessels, over 2 journeys, which means your embedded carbon for that fuel is 50%. If you keep doing this, however, that becomes circular carbon. You do that over time. The carbon is just a framework to which you attach the hydrogen, and you burn it off, and you put it back, and you burn it off, and you put it back, and so on. So it becomes a way of holding that carbon. The beauty of this approach is the vessels come to you. You've got the port. Carbon just arrives because they want to get rid of it, and they want to get hold of the clean fuel. From there, you can then get a bunker barge, move it to Mossel Bay, discharge it at the port, and you've got a very reliable CO2 supply. This is dependent, however, on a proper life cycle assessment model. I hope that addresses some parts of your question. It's a long discussion, but there's one at the back.
Can you just make a few comments on aviation?
Aviation. Aviation and maritime, they're like a brother and sister. They're both controlled, they deal with travel in international airspace or international waters. The regulatory domain from that is notoriously difficult. You can make rules for what happens in your territorial space, but what happens in international space is more difficult. European Union can do for their collective space, but outside. So, the aviation community, the International Civil Aviation Organization, has got a fair idea about where it wants to go. It also has a net zero 2050 target, with no clear way of getting there. It has done a lot of detailed work to go and say, we can have low carbon fuels, which essentially means you just strip out it's a more efficient way of using fossil fuels. You get rid of flaring, you do this, you move the fuel with electric vehicles, all that sort of stuff, but you save maybe 10%. You're not going to do any deep decarbonization. There is the non-drop-in fuels, the really exotic ones, where you use hydrogen on board an aircraft, or ammonia on an aircraft, something like that. That's possible, but ICAO has discovered that you're not going to really do more than maybe 10% of that. The remainder is what we call sustainable aviation fuels, and those are drop-in fuels, either biological in origin or e-fuels in origin with captured CO2. Now, while there's broad agreement that that's the way to go, there's no enforcement mechanism. There's no compliance mechanism. It's all voluntary. And if it's voluntary, not much happens. And ICAO has, I don't know this personally, but I know this from what I've read, ICAO is largely dominated by the industry. So there are many lobbyists from the industry saying, but we can't do this, we can't do that, this is too difficult, we can't go there, blah, 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 which means we're not really seeing terribly much progress. So we have, citizen has been supplanted by corporation, which makes things difficult. With maritime, the ambition is stronger, the possibility to get there is closer, we just have the petrostates that are standing in our way, if that makes sense. Does that help, Karen? Are we good now? Yes. Must I go? Yes. No, okay.
Can I just ask a small question? Please.
Okay, small, please.
Just Thomas, please.
Well, you sound like a professor to me, and I love you. I study everything that you teach. I'm so convinced with what you're saying, but I'm also very scared.
Yes.
Because on one side, we've got all these energy mixes
yes.
that are brand new.
Yes.
And some some of them are working, but they can't do certain things, like you say, shipping and so on the other side, we are against time.
Yes.
And even in South Africa, I'm 59 years old. I grew up without tornadoes and flooding, and these things are a reality.
We are the same age, ma'am.
Oh, thank you. We are experiencing these things, and they are chaotic. Anywhere, everywhere you wake up, there's a flood. So we clearly are seeing examples of the fact that there's no more time to do research and to convince ourselves and to justify why it should be cheaper. And what should justify it is the fact that this planet is in chaos, and we've got to find a way of selling that than selling the cheapness of technology. Whether the technology can be cheap, etc., etc. We've got to push it in the direction of the fact that if I look at South Africa and I look at Cape Town and I look at Camps Bay, I am scared of those people who are living in Camps Bay, because they're going to drown. Their houses are already drowning. And if industry cannot be pushed, if it's looking after its own interest of making more profit, at the expense of the entire nations of different countries on this planet, then we as the masses, we should not cry when things go hayway, because we have not put our foot down to say to the industries, you cannot continue like this. Because I don't know if you can advise, I sit and think, they say we shouldn't reach 2%, 2 degrees Celsius of heat. Otherwise, if we do, we're dead. So I'm thinking, how are we going to reduce this if the industry is still refusing? If the technology is going to take time to develop, because the industry is not prepared to allow people like yourselves to go and institutions of higher learning to go out there and develop these things, because there's no backing. So what should we do? What must we do to get to reduce the temperatures by less than 2%?
Tell you what, ma'am, I have a strong pressure from here to do something. I'm happy to discuss it further, but I think I will describe it as shortly as possible. As I'd like you to imagine 4 circles. A circle in the top left, a circle in the top right, circle bottom left, circle bottom right. Each of this represents a community of people, and each of those people operate according to a set of rules. But the rules are different. Top left is the political sphere. A politician lasts 5 years. So he wants decisions made that allows him to get benefit within 5 years, otherwise why do it? Top right circle is the environment, where the environmental scientists and activists, they want to get the 2 degrees or 1.5 degrees. They want action now, and the cost that it takes to get there is someone else's problem. The economic bottom right, they have to stay employed. They have to stay economically active, otherwise they will go out of business. They can only do that if someone's going to buy their product. Someone will buy their product if there's a regulatory environment which supports the purchase of that product. We have managed to navigate this before. Solar didn't fall from the sky. Solar was exceptionally expensive. It was used on NASA space stations and all that sort of stuff. Yet now it's very cheap. Why is that? Because the US federal government spent a lot of money in the 70s. Because the Japanese government spent a lot of money in the 80s. Because the German government spent a lot of money in the 90s. And as a result of that, that price then dropped. We just in a different phase now. Now we need the same with hydrogen. The last group over here is your social, your communities, your employees, your trade unions, your civil society. Each of these 4 groups have their pressure groups, they have their interests, and the projects which succeed are those where those 4 circles interlap. That area is very small. So we look to find those projects which can allow those first tasks to do something. We bypass the fact that things are expensive by having government fund pilot projects. But that's not scale. But that means something happens. There are certain niche areas where something can happen. So I used to feel like you do. being very upset about things. Then I realized I just get tired. So now you just look at those areas. Where can you find that very small area where something can happen? And maritime looks like one of those. But I'm happy to chat afterwards. I hope that helps.
A round of applause. Thank you, Thomas. Just an apology from one of our speakers who will be talking about the East London IDZ Renewable Energy Academy. Ayanda Ndiseni won't be here. So we have a replacement for him or her. I'm just going to quickly read the bio. Dr. Karen Sarich. Okay, perfect. Dr. Karen Sarich was awarded her PhD in 2007 by University of Pretoria, and during her time, she was during 2007 to 2009, she was a postdoctoral fellow of the Claude Lyon Foundation. Her academic career was paralleled by establishing a consulting company specializing in environmental analysis, environmental impact assessments, lab setups and establishments, and consulting to, amongst others, large energy, environmental consulting and metal industry in South Africa. It offered environmental compliance services in mega industries like steel, energy, and mining, with scarce expertise in soil immolarization from the lab, and collaborating with who test and pilot the United Nations Sustainable Development Goals and South Africans' energy security, efficiency, and technology innovation needs. This includes projects to demonstrate sustainable technologies that are fit for purpose in South Africa, in collaboration with researchers and various international agencies. She has led to successful piloting of sustainable energy and efficiency solutions to lower the country's greenhouse gas emissions and support a just energy transition. Can you please kindly give a round of applause to Dr. Karen? Thank you.
Thank you so much. Goodness, it's a long bio, and people write things for you, and it says brief one. But thank you so much. So I was asked to step in and just give a bit of an overview, and I think a lot of what I'll talk to will be what the lady was just raising at the end of Thomas's talk. So this is and I'm hoping at some point it will pop up on the screen. I'm pushing the button. Okay, I don't know when it's going to pop up on the screen, but I'm going to give you a bit of an overview on decarbonizing energy. So just before we launch into that, for those of you that are not aware who SANEDI is, we are the South African National Energy Development Institute. We report directly to Department of Electricity and Energy, and that important document that was in the media yesterday is one of the ones we worked on, and it talks particularly to this policy information component of what we do. So our main focus is looking at technology, RD&I, providing thought leadership and managing data in that space. But a lot of what I do at SANEDI is actually managing and building pilot projects with linked capacity development in that space. So having said that, this decarbonizing and this word that we throw around, decarbonizing energy, what does that mean? How does it work? It's lots of big words, but as the lady was just saying up there, we're talking about this, but what does it really mean? What are we doing on the ground? So what does it look like globally at the moment? Globally, as we sit here, we are using the resources of 1.7 planet Earths. So the last time I checked, we only had the one, so this is probably not sustainable, which means we need to find another way of working more efficiently and more responsibly with our resources to be able to deliver what is needed. At the moment, we are sitting on well, this was in the beginning of October that I drew this down, but I love this website. It's called Worldometers. It's got lots of info. But in 2020, on the 10th of March, our world population was about 7.7 billion. And in the beginning of October this year, we were up to 8.2. In the last 5 years, we've had a global pandemic and we've had a net growth of 500 million humans on the planet. So this is not sustainable. All of them need to be supported. All of them need water, food, shelter, and energy. Talks to the master of all of that. So there are many that believe, I hope this will play. Oh, but it's not playing, never mind. There are many that believe that there's no such thing as global warming. This is a video which I'm going to describe to you but isn't playing, that basically shows that we're already actually past that 2-degree mark and we need to be coming back. And what is the impact of that? It's exactly this. It's exactly what we're saying. Strange and unusual, exacerbated weather phenomena like tornadoes in Durban. More severe weather phenomena that we are seeing. Shrinking of glaciers, loss of species, poverty and displacement is the result of all of this. Now, all of this climate change is happening because we are not moving fast enough towards decarbonizing our energy. Now, on the planet, we only have 3 sources of energy available to us. We have our fossil fuel friends, we have renewables, and we have nuclear. So what we need to be doing is finding a responsible way of working with all 3 of these guys, because if you focus on just one, you lose your energy security aspect. So they need to be responsibly blended towards decarbonizing the energy sector. So there's a number of reasons why we would want to decarbonize energy, and the first one obviously is climate action targets. But if you walk down the street and you say to somebody standing there, why do you want to decarbonize energy? They're probably just going to blink at you a few times. But their answer is definitely not going to be climate action targets or sustainable development. It's going to be more linked towards this. They're going to say, well, is it going to cost me less for my electricity if we've moved into a decarbonized state? Because bottom line in my household, the economic status of it is what will make me shift. So if we start to look at South Africa, and we drill down now, we are having the dubious honor of being responsible for nearly 2% of the greenhouse gas emissions globally. But our economy doesn't parallel that. We are the highest greenhouse gas emitter on the continent, and we are home to the largest point source of CO2 emissions. Incidentally, the spot where hydrogen is being manufactured for many, many decades as well. So what is the effect of this? And Thomas alluded to a lot of it in his previous, in the previous presentation, and that was we have to meet these decarbonization targets, particularly in an industrial space, in order to be able to maintain our export markets, which of course impacts our economy and grows or shrinks our economy. And one of the big components to consider there is that the effect of us not decarbonizing means that things like the CBAM, things like stranded assets because of industries that are collapsing, all results in job losses and an economic downturn if we don't start moving in that direction. So we have to find a way of moving into that direction that then allows us to be able to still be energy secure, grow our economy and use all our resources more efficiently to meet that growing population. So South Africa's current energy mix is pretty coal heavy, as we all know. And we are supposed to be moving towards a more responsible energy mix for a number of reasons. Some of them relate to decarbonizing energy. Others of them relate to the fact that fossil fuels are finite. So if we are heavily dependent on the fossil fuel component here, the green and the blue, we're going to have a problem if we run out of them. So we had the IRP that came out in 2023, and basically that mix looked a bit different. It looked a lot more secure in terms of having a blend of energy that would allow us to have energy security while growing our economy and meeting our energy needs. This was the 2023 release. This was yesterday's release. So essentially what we're seeing now is a lot more renewables coming into that space and a lot less coal into the future. This is to 2039, by the way. So we're also seeing that if we're going to have all these renewables, and of course looking after renewables and a bit of cleaner fossil fuels means I fit in this whole space with what we do at Sanedi. But we need to be considering, if we're going to put all of these on the grid, we need to stabilize them. They are intermittent. So a lot of the other technologies will need to support them. And that is what the IRP says. How do we integrate our resources, use them responsibly towards a secure, economically growing future that meets our needs? I just put a couple of slides in here on the just energy transition, because if we are moving towards this kind of mix, what will happen? We have to transition. It means new skills, it means new assets, and it means new components that need to be serviced in that space as we move towards decarbonization. So if we start looking at electricity for South Africa and the way we stand at the moment, our coal fleet is getting towards the old-timer phase of things. So if we look at our average age and our design age of our coal-fired power stations, average, we're already above what they were designed for. We've got our two young guns who are now synchronized to the grid, but we've got a lot of old-timers that are going to need to be retired. And all of those new energy mixes that we see coming in will need to fill those gaps. And that's why the just energy transition is also so important. Otherwise, we will lose energy security. I always like these slides, and this is from week 39, but essentially the Eskom releases this every week, and it tells us what our energy availability factor is on the grid. So what we want is above 70%. So as you can see, it wasn't looking great the last few years, but we've been looking a lot better last year, which is our green one, and this year, which is the purple one. So we're starting to see that energy availability factor picking up, and this is why everyone's excited, because load shedding's over. However, the minute that we do start to see some electricity constraints again, you will see another boost in the alternative energy sector, if I can put it that way. So what are some of the strategies, and I'll talk to that in a minute, of decarbonizing energy? And here is just a few of them listed, but your first step out of the gates is efficiency, always. Because if you're going to build assets to meet your need, you don't want to overbuild. It makes everything too expensive, and it has a negative impact on the economy because of it. So we first go energy efficient. Then we move into other technologies, and we look at what do we need? Do we need electrification? Do we need to switch from fossil fuels? What's our potential on hydrogen? We already have hydrogen. We now need to move into the rainbow of hydrogen. And green one seems to be the predominant color there. Why? Because that's what we're being pushed towards for decarbonization, particularly in the global space, to make us economically competitive. And finally, of course, there is a CCUS component to all of this, which South Africa does have considerations and goals and targets towards. So if we start looking at decarbonizing, we're looking across multiple sectors. Now, what the big focus of this conference is that we're looking in the industrial space, so we're looking large scale. But essentially, large scale, we need to be shifting to cleaner energy sources, but again, with efficiency up front there. Possibly capturing our emissions and either utilizing them again or putting them somewhere where they are not going to cause environmental damage. And then, of course, sustainable practices. So whatever we're going to do needs to be sustainable. So once again, it talks to that life cycle assessment component. So just a bit of a tech overview, and I'm not going to go into all of this. But there are different types of technology that fit into different spaces or components, if you like, topics, underneath the decarbonization theme. And I'm sure these slides will be made available to you. But ideally, what you want to be doing is looking at how do we integrate diverse technologies with each other to still meet the energy needs, but be able to integrate them in a stable and sustainable manner. So, oh, good, it's showing up. Sometimes this map's a little bit invisible. So recently I was presenting at an international energy agency, the PVPS, the PV Power Systems executive. And the day before me, my colleague from China presented. And he presented that in the first 3 months of this year, they built something like 240 gig of PV behind the meter. The following day, I had to present on South Africa. I was absolutely delighted that load shedding pushed us to put 6.9 gig behind the meter on the private sector in the last 18 months. So the scale at which we are doing things and the scale at which the world is doing things, we need to start considering how do we move into that space. But of course, we need our own industries in that space to be able to be producing like this, because here they are producing, they're consuming their own product and they're selling it to all of us. So it's definitely something to consider, but the globe is moving towards renewable energy capacity, and of course all the technologies that support that towards energy security is what helps us grow our economy. So South Africa's goals and commitments, of course we have climate targets, which are directly linked to economic growth. So we are, yes, committed to our nationally determined contributions, but that transition into that space has to grow our economy. Otherwise, there's no point in us doing it. So if we look at our key interventions in South Africa, we've got our renewable energy. So we've got large-scale renewables coming online. And then thanks to the motivation of energy insecurity, we have a lot of renewables also coming online from the private sector's investments. Grid modernization is going to be important. We're going to put all of what we just saw on that IRP pie chart onto the grid. But we've got a grid that's 45 years old and bits keep dropping off it. So that grid needs to be modernized and needs to be able to meet what we can do. And that talks to a lot of smarter technologies, integrated technologies, AI and so forth. We have to transition our coal plants, not necessarily because we think it's a good idea and it's environmentally friendly to do so. Yes, those are components. But because some of them are so old that their emissions are so high and their productivity is so low in terms of efficiency, it's not worth keeping them running anymore. It's starting to get too expensive. Then we've got the just energy transition, which fits directly into that. So if we have to transition, we have to do it in a just manner, and there's a whole plan around that. And finally, we come into that space which is it's not in the short term at the moment, but it's definitely in the short term in terms of we need to start now. We can't say, oh, green hydrogen is something that will be on the market in 10 years. Yes, it might be on the market in 10 years, but now is when you need to be starting to build it and work with it. You can't in 10 years' time say, I'm going to start now, because then it's 20 years down the line. So new energy vehicles, things like green hydrogen, hard-to-abate sectors that are addressed with energy security are things that need to be addressed now. And I think we're moving towards the last. We've got a few challenges for decarbonizing in South Africa. We know we are heavily reliant on coal. We know that we have some financial and operational issues around, although Eskom's turning a profit at the moment. So maybe the financial issues are a thing of the past. But there are some issues, and we know that our grid infrastructure is aging and it needs upgrading. It also needs smartening and so forth. But there's a large socio-economic impact as well. If you don't get society to buy into what you're doing and move forward with you, you're dead in the water. It's not going to happen. So society has to be there with you. You need policy uncertainty, Thomas, to be addressed. Thomas mentioned, you've got this circle of politicians who are only interested in the 5-year horizon because that's how long they're there for. So whatever they're going to do is only going to give them a win in that space of time, which creates a bit of uncertainty because we're not building a power plant for 5 years. We're building one for as long as we can keep it ticking over. Some of the old guys there are going for 60, 70 years. And then, of course, we have funding gaps because all of this costs money. I love it when people say, oh, free energy from the sun. Yes, the sun's got free energy, which, by the way, is a large nuclear reactor. But harnessing that energy is not free. Integrating it into your grid and your economy is not free. So there's always funding that has to come with that. So that, of course, because there are challenges, we create opportunities. So we do have an abundant renewable resource, which is free. So what we need now is to be able to harness that. We do have our IPPs that are coming online that are feeding onto the grid, and that will become more as the policies are becoming more conducive. We have strategic projects and economic diversification already underway. And of course, the policy and the planning in that space, by example of the IRP that was released yesterday, is also starting to parallel what's happening there. So we are moving forward. And the international support that was spoken about in the previous talk as well is the funding that's coming in internationally to move towards this space, because we are all on the same planet. As far as I'm aware, until Elon gets his act together, we're not going anywhere. So whoever's burning stuff here, it's affecting there too. So that's why we have this global funding and capability that has to be leveraged, that has to be accessed and harnessed. So this is my second last slide. In the evening when I have nothing else to do, except for that whiskey on the rocks, which hasn't arrived yet, by the way, I'm just saying. I think about these sorts of things, and I try to organize in my mind, what do I think would happen to the energy mix in South Africa? And there's three main components that always come forward for me. The first one is the policy, because if you don't have the policy and all the regulations and all the bits and pieces that plan around behind you, then you're pushing the barrel up a hill with a wet rope, because nobody's supporting you. You need the technology to be able to do whatever it is that you're wanting to do in that space, but you also need society behind you. And society has to really drive that uptake of technology. So, I mean, I bet you if I ask you now, everybody in this room knows what the charge is on their cell phone at the moment, and they also know when they're going to charge again, and they know where they're going to charge and how they're going to charge, and they've got a backup charge in case they need something. We need to be thinking about our energy sector like that, and that's what the policy and the technology is designed to address. So on that note, I will thank you very much for your attention, and I'm happy to take questions. Thank you. Is it? Oh, our chairperson's coming, but yeah.
Can I ask from here? Thank you very much, Karen. Your one slide, when you spoke about your energy mix, and it was accurately energy rather than electricity mix, and then went on, and then the remainder was largely on electrons. Does SANEDI do, well, I know you do work in fuels and stuff. Do you want to chat a little bit about that? Or is, yeah.
Yes, so within, I didn't give a breakdown of SANEDI and all our components and all our sub-programs, but we have a biofuels sub-program at the moment, which I'm looking after, and we are looking at an actionable, realistic biofuels policy information document, which will be released in next week, actually. So we're almost there. There's a large stakeholder engagement next week, and then from there we will be releasing this document. And I'm back on. I don't even know where that came from. One of the things that I've been stressing as managing this project moving forward is that anything that goes into that document has to actually be doable in the short, medium, and long term. So there can be different components, but it has to be doable. So it doesn't help if we say, oh, it would be great to do this, and it's something that's pie in the sky that will take 40 years to get to. It has to be doable within the next 5 years. What can we do? And there we look at feedstock, technology, and product. And then we take it over different spaces. So there's a biofuels component. It's looking at liquid fuels, but our plans are to then expand that into bioenergy space. Having said that, we've already done a number of pilots in the biogas space at different scales, and we've got some successful pilots in particular spaces that we feel actually addresses a need. So I think in my bio that they read, and that was one phrase that when they were writing the bio, I did insist, was that we put down technologies that are fit for purpose. So it doesn't help that we adopt a technology from somewhere and it does something, but it doesn't really work here. It has to be adapted. It has to be fit for the purpose that you want it here. So just like you wouldn't build a coal-fired power station on the top of your house, you'd rather put a PV panel up, same thing. It's got to be fit for purpose. So I hope that helps to answer that. But the answer is yes, we are moving into the fuel space. And of course, there's the green hydrogen work we've been involved with, linked to yourselves and so forth. Any other questions?
Hi, Dr. Karen. I'm just interested in how feasible the 2025 IRP is. Looking at how much of coal has been shrunk, and also thinking about the jet the fear that it's going to erode a lot of employment in a country that is already facing the unemployment rate that it's facing. So when these documents are being written and timelines are being put in place, are we really realistic? I mean, if this is until 2030, do we have the technology to do exactly that, which we seek to achieve from that pie, that graph? So I just want to know that this is not like a research kind of process, but more so something that's realistic. And you almost touched on it to say, you know, things have to be realistic. But I'm just interested to know, are we really being realistic? And with the timelines that have been set, are we really being realistic?
Okay, thank you. So at the risk of my general manager smiling at me from the back there, so at the risk of, I'm going to have to put on a civilian hat for this answer. So the IRP that was, shall we say, the minister held a press conference on yesterday. So that pie chart that I showed came from those slides, but it was percentages that I showed. So actually, in actuality, that pie on the second slide is bigger than the first slide's pie. So the amount of coal that's on the first pie is the same as the amount of coal that's on the second pie. It's just that we're growing the energy that will be available, or that we will build, with additional technology. So we're not building new coal, but the coal that we have will continue to tick over. So I believe one of the things that was raised yesterday in the press conference was that we are not looking to shut down any coal that doesn't have to be shut down because it's at end of life. And we're not looking then obviously towards job losses. Having said that, in any industry, if something is having to shut down, there would be job losses. So what would then happen is those individuals would reskill or upskill, not reskill, upskill, and transition into another space. And that's really what the JET is about, that just energy transition is. Firstly, there are new components or new people coming into the job market. They're coming into a job market that's going to have an energy mix that looks like that, or that's moving towards that. And we are obviously growing the amount of electricity that we will have for South Africa onto our grid. So we have like a 50 gig grid at the moment. It'll be a much bigger grid, but our coal will still be there. Then we will have all those others that you saw listed there that are talking to it. What was interesting for me was the massive injection of wind and PV that will be filling up that other, it's almost as much as what will be on the coal in the long-term plans. And this is to 2038. So I think to just address your two concerns, the one was, you know, job losses and the shrinking of the coal sector. So it's not shrinking in that sense of the word. The pie is actually bigger on the other slide. And the second one is the timelines. So these are timelines that have, look, the IRP is not something that somebody sat down in one afternoon and thought, let me write down something that sounds nice. It's been going backwards and forwards for years. It's also a dynamic document that's constantly receiving inputs. And so the way that it looks at the moment, those are probably ambitious but achievable targets if the right, and those three things I had on the last slide, policy, technology, and social, is in place. It's achievable, yes. Okay. I'm seeing multiple hands.
No,
okay,
after
Francois. Thank you.
Thanks a lot for the presentation. Just on your last chart, right? So if I think about what's been happening, we had some subsidies for solar thermal or solar geysers for a period of time. That came to an end. More recently, we've had for PV, you know, for the adoption at, you know, of society, to your point. Right now, large-scale PV is paying for itself, or like it's a really good business case. Where are you seeing the next wave of support, of incentive and or subsidies to you know, kind of keep the acceleration on?
Okay, so that can be answered in one of two ways. So my first step out of the gates would be look at your first fuel, look at your energy efficiency. There's a lot of incentives in place for rolling out energy efficiency measures. A lot of those are governed or sort of incentivized through SANEDI, and the manager that works with that is sitting at the back of the room there. She spoke this morning on it, but things like your energy performance certificates that are meaning that buildings must comply with a certain level of energy performance, which means energy efficiency and alternative energy sources. So there's almost like the stick, that's the stick, and then there's the carrot, which is the incentives in terms of tax rebates, in terms of anything that is going to make it a smoother transition. So I want to say almost an indirect component would be if you put PV on your house, you're paying a little bit less on your electrical bill. If you put anything thermal that's supporting, for example, your geyser on your house, you're paying half the electrical. So there's sort of that indirect component. Yes, you have a upfront capital expense, but if it makes sense from a business perspective and you can work it out, then it's worth putting the investment down if you have it. Having said that, on the technology side, I don't think, for example, that we're going to see wind getting a, put up your own wind turbine and we'll give you 50% back. It's not going to happen. But other technologies, I think you're going to see this sort of indirect component where you can claim back your tax, or you can have less expense on your electrical bill or so forth, and that will be what drives in that direction. Yeah.
Thanks.
Okay. And then I think the lady behind had.
There isn't any person who had their hand up. Okay. I've got just two questions. And then I want to give the environment, everyone here, I want us to be scared and live on the edge, and each one of us must own up this thing and do something, but I'll do that. My first question is, what kind of advocacy can we do, and who is responsible to do advocacy to the citizens of South Africa to be aware of what is happening? And the second question is, what is it that as a citizen we should do to mitigate? Because I believe we own up. There's stuff that we can stop that can help in the whole process. Can you answer those? And then I'll just give this example quickly before we leave.
Thank you. So I think both of those questions talk to that social bubble that I had on the bottom. And remember, I said if you don't have society behind you, you're dead in the water. So you are very accurate in saying, what do we do as the average Joe in the street or Jane in the street to make a difference in that space? So there are obviously a number of initiatives out there. We are starting to see energy and energy components coming into the education system. We're starting to see it coming in at different levels, so primary school, secondary, tertiary, so forth. But it almost needs to become like a second nature to people, that this is something we consider. Now, in South Africa, we have very limited water supply. We know that. It's always been like that because we're not a water-rich country. And yet I still see people opening a tap and then wandering off somewhere. So it's more a case of trying to, and this is really the most difficult component. Technology and all those kinds of things can be there, but to get the human behavioral component to be compliant is the most difficult thing, because people have got to change the way that their normal is to be able to do that in that space. And then also care. So maybe they need to think, okay, now that water is pouring down the drain, somebody could be drinking that, but I'm using it to make nice sound effects while I walk across the room. It's very, and it never completely makes sense to me. I mean, I watch people, I do recycling at home, and then I watch people go, I don't feel like putting it in the recycling bin. The recycling bin is 3 steps from the other bin. But they couldn't be bothered walking the 3 steps. So it's really become sort of a mindset and a cultural thing. And the only way to adjust that really is hit the primary school level, and there's nothing like an 8-year-old child saying, Mommy, it's the wrong bin. That will resolve all the issues in the house. So all I can say is we really need to be starting this at exactly as you say. There needs to be an education, and sort of the normal of how we behave must start young, all the way through, so that by the time you get to adulthood, you're not even thinking of it. This is how you operate. You operate in a sustainable, efficient manner. So I think that's all I can add in that space, but let me hand back. I'm getting sneaked up from the side.
Can I just...
Dr. Karen, a round of applause to Doctor.
Can I just share this story quickly so that we can change? It's going to be quick. It's going to be quick. I promise. I promise.
Can I just close out and then you can share quickly?
Oh, yeah, that's fine.
Thank you so
that's
much,
fine.
colleagues. We're going to have break time, tea time. We stole 10 minutes of your time, so be mindful of that. The next session will be talking about sustainable energy finance.
Financing. So, yeah, you don't want to miss that. It's about the money. And let's have a look. It's now 3:05. We were supposed to start the next session at 3:15, but we're a bit late, so
20 past.
20, if you can be back by 20 past, so that we can start at 25 past, then you can all go home before the traffic.
Yeah.
Okay.
I think.
Can I just, I'm going to stand up because
thank you.
This is really, it's a thing that I wish we can live it. You remember the floods that happened in KZN in 2023, around April. What happened? It was a freak accident, and it happened again last year in the Western Cape. Remember there were floods that came in some of the towns on the towards Hermanus, the ones on the coast. There was also flooding. So let me explain. And this, I don't think we will ever have a solution unless we change our ways. What happened with KZN and that other municipality was that we have a low pressure system that comes from the Indian Ocean. It hits Madagascar. It moves at a slow pace, as if it's standing still. It drops so much rain on the land, and then it moves to Mozambique. And if it doesn't dissipate, it then came down to Durban. And it was like this thing is standing still. But the most scariest thing that happened at that time was that it was the time when we had full moon. I'm a land surveyor. We do tides tables as part of hydrographic survey. Then when it's full moon, we have the highest tides. Earth has got tides. They become higher to about 5 meters next to mountains. And the sea tides, they also become higher. Now, at that same time, when the earth was saying, there's too much rain, I need to push it into the sea said, no, it's high tides. Because of the full moon, their tides are higher. I'm pushing the water into land. That's what happened there. So the land became oversaturated. Now, because the land was oversaturated, and KZN, guys, we've got to really think about what we're going to do. KZN is in trouble. KZN is a humid environment. There is no bedrock in KZN. Those beautiful hills, they are beautiful because it's just soil. Bedrock is gone. There's nothing that anchors that soil. So when you tell people, do not build in the flood line, it's fine, but they are not safe either living on those hillocks, the beautiful hillocks, because they are not safe. We had mudslides because of oversaturation of water into that soil. We're going to have that devastation continuously as long as we are not changing the way that we are doing things. Western Cape was lucky because those municipalities are on a very hard surface. They are on bedrock. So when that water came in, it did not have the same level of impact that it had in KZN. Those coastal areas in the Cape is the same. If you look at the hills, they are beautiful, they are green. We love them. They are dangerous today because there's no bedrock to anchor that soil. It's going to mudslide. Our people are going to die en masse continuously. So where do we run to? Floodlines, you're going to be flooded. Hillocks, you're going to be slided. We've got to think. We've got to have passion. We've got to worry. We've got to rally around KZN in Eastern Cape. We are going to continuously have this mess. It's a freak of nature. You cannot even imagine or predict it. It happens. We're dead. So please, let us all be worried and frustrated and do something. We can't have a CSIR having sweets with plastics. when he's teaching us about climate change. Come on, guys. We're talking something, we're doing the opposite. What is wrong with us? What is wrong with us? Are we serious? Thank you. You going to that? Oh, let me not leave my phone. Oh, I think I must go, but I want to.
Take a seat, please come in, come closer down. We're about to finish off the day on a high note, I'm happy to say. On a money note, on a bank note, yes. Colleagues, thank you so much for coming back after the last tea break for the day. It's been quite an interesting day and a very a long day, but really very valuable. My name is Leander Reiters. I'm with the National Cleaner Production Centre. I'm the portfolio manager responsible for all of our initiatives on industrial spaces. And it gives me great pleasure to host this final session of our first day of the Sustainable Industrial Spaces Conference. Our last session was designed in such a way so that we would get everyone back into this Ruby auditorium after having split into 2 sessions after the plenary. And we thought it would be fitting for us to end off today with the financing issue. And we heard in this morning's plenary, and I think throughout the day, numerous references made to the importance of finance when we have to look at the opportunities with industrial spaces, and of course, addressing the issues around sustainability, decarbonization, and energy. So we wanted to get onto this session, the colleagues that deals with finance and that deals with also issues of industrial spaces. And we're really happy to have a speaker from the Industrial Development Corporation here, Chisakula Kaputu. He is the Senior Energy Specialist at the IDC with over 25 years of experience in extractives, energy, environment, and sustainability, working with industrial mining, academia, DFIs, and also energy and risk advisory. He's a holder of a master's degree in engineering. He has numerous other qualifications in project management, financial management, sustainability, leadership and marketing, and he's also a certified energy manager and certified measurement and verification professional, which is a recognized UNIDO and EU energy expert in section 12I and L tax incentives. He has got a vast amount of knowledge and working experience in energy management, energy efficiency, in energy supply, renewable and alternative energy, and energy engineering, and has advised governments, international financial institutions, and private sector clients on energy and sustainability issues. Please give a round of applause to Chisakula.
All right, thank you, Lee, and good afternoon, everyone. Staying in for the graveyard shift, as they call it. Thank you for, staying on. Interestingly, we're going to talk about the first thing we think about when we wake up, money. It's going to be the topic of discussion, financing, basically. I'm from the IDC. I need to know where the clicker is. Right there, sorry. Okay, moving so fast. That is my presentation outline. I'll talk about, obviously I'll introduce the IDC for those that are not familiar of the IDC, the Industrial Development Corporation. I'll give a little context on sustainable energy finance, the IDC's approach to financing energy projects or infrastructure. We'll have a case study. I was hoping that Kuka would be here and speak before me and preempt my presentation. But nonetheless, I'll have a slide in that sense. And of course, the contact us is just the contact details for the IDC for those that want to contact us. By way of introduction, this is a loaded slide. In any case, some slides are quite loaded. The idea is so that they can be given out and you can read through them in your own time. But for those that don't know, the IDC is a DFI, Development Finance Institution. So basically, we are a government agency that provides, let's call it patient capital and long tenure kind of loans for development aspects, for developmental projects. We're different from a commercial bank purely because of maybe the interest rates that we're charging and the tenures and the patience that we provide with regards to the financing. This year we celebrated 85 years, so it's an institution that's been around for 85 years. Some of you may be aware. This is our value proposition. Basically, we're providing advisories, solutions, and also funding, fundamentally funding, that's the key. And we're partnering to grow the economy, when you say developing the economy of South Africa, principally, and the rest of Africa. So we are into the rest of Africa as well. Okay, this is what we provide. So generally, the IDC has, I would say, 10 focus sectors. So anything from manufacturing, tourism, right through to filmmaking, for those that are not aware. So we do fund those undertakings. Principally, we provide loan funding, and we also provide equity funding. So we have stake in some of those undertakings. So this is generally what we fund. I included this slide just to speak to the element of sustainable energy or sustainable financing. Speakers before me have alluded to the issues around decarbonization and energy security, and also the aspect that we should use our resources sustainably so that the next generation, the future generation, could also use them. We speak to that as IDC, so we invest in the future. We also, as a DFI, have serious KPIs, some of them also including industrialization. So we look at areas where we can provide financing to catalyze industries in those sectors. That's why this session is really important for us. So this is the IDC supporting industrial capacity development, as I've indicated already. I won't talk to this slide, but I mean, you can see how involved we are in terms of bringing together the various elements, whether it's industrialization or it's taking care of the environment or an inclusive development. So one of our transformation matrices obviously is how are we transforming the South African economy? You know, we also look at jobs creation. You know, we're sitting at Q2, 33 to 34% unemployment rate. That concerns us. With regards to our sustainable industrialization, we have 4 themes across, ranging from obviously catalyzing low carbon and green growth, right through to a regional value chain. So somebody spoke about new energy vehicles or so the battery value chain. We are in that space as well, from mining, beneficiation, right through to product development. So I'm sharing this slide just for context, obviously, so for those that may be interested beyond the energy. The energy, like I said, there's various units within the IDC. So there's the energy unit, which looks at basically we're saying we're facilitating the South African energy transition and ensuring sustainable energy security. One of the roles that we're doing is we're participating in the industrial zones program. So that's the unit that's been born out of the DTIC. We're also part of the DTIC, and they're housed at the IDC. So we support those functions. So in our functions, we're working across the SEZs, special economic zones, and industrial parks, and the rest of them. So our key focus area, that's now the energy unit. So we provide funding to renewable energy power generation from utility scale. So we participated in the REAP program, right through to in the C&I space, behind the meter solutions, you know, providing funding for solar, wind, bio. You could take a shot of the slide, but you're going to have these slides anyway. I'm sure you're going to have them. Yeah, so that's what we do as the energy unit. We've given a use case here of Pellegrin Energy that we funded at HODCO level. So the issue we brought in here was to why do we fund sustainable energy, and why is sustainable energy financing, what does it matter? So obviously one of the important issues is we also want to drive resilience and competitiveness in the industrial sectors, spaces. So in the special economic zones, in the industrial parks, both private and public. We've also been made aware since morning, and in fact, borrowing from the one before last presentation with regards to the issues around energy security, you know, the affordability thereof, availability and accessibility, and sustainability, of course, is a key issue. We have recognized financing as a key enabler, obviously, for the transition. We're talking about transitioning, the various transitions anyway, energy transitions. So we're talking about the transition from the high carbon intensive energy resources to the low carbon energy resources. And we are playing in that space, obviously, as IDC, not only so that we can sustain the South African economy, but also we can preserve the environment, so to speak. So those are the issues that I think have been spoken to by other presenters. Our approach to funding the energy infrastructure investment. So like I said earlier, we focus on providing funding into the utility scale, so the REAP projects, the base now that have come in, the risk mitigation that was there, any of those Section 34 ministerial determinations, we provide financing. We also provide funding for embedded generation, so the behind the meter, you know, in the commercial and industrial space. We also now, obviously, with the emergence of energy traders and aggregators, we are also playing in that space. You know, we're providing funding either for them to secure the deals with the independent power producers, sitting in as in between. The transmission projects, of course, you know, are aware of the independent transmission project that's now coming on to provide capacity to evacuate the let's call them the stranded assets that are sitting, say, up in the Northern Cape, because there's not enough transmission grid. So IDC is also playing in that space. We are interested in participating as a funder. The financing instruments that we have, like I said earlier, is anything from senior debt to equity participation and anything in between, the mezzanine solutions, and provide blended finance as well. We work with other DFIs. Our project criteria, principally we look for projects that are bankable, so we have a very rigorous due diligence process that looks at the financials, the technical, the marketing aspects, so the power purchase agreements or the off-takers, and the legal thereof. We are also very, very interested in the developmental returns. So as a DFI, we want to see that the project has some transformation in there. It's looking at job creation. You know, we are very much interested in black industrialists and women and the youth as our key performance indices that we report. Maybe this could be like a repeat of the previous one, but we're just giving a range of various other opportunities that we may consider funding as the IDCs. So there was a talk about hydrogen, the green hydrogen. We are interested in that space. We have looked at waste to energy in terms of biomass. We have invested in a waste to energy facility already. So that's a range. So our funding solutions, I've just given a schematic here to indicate how we fund. So we'll fund into an SPV directly. We can also fund on balance funding into a company which then provides the energy solutions. for themselves, so that's on consumption or captive power. But we also would fund an ESCO, an energy services company, that would then provide energy solutions to various other off-takers. The case study, Kuka Special Economic Zone, we have, this is their scope basically. They're looking at 5 rooftop solar PV installations within the Special Economic Zone. So utilizing the rooftops of their infrastructure, they're going to put up these solar PV solutions. They'll create an SPV. They're calling it Kuka Clean Energy. So it will be wholly owned by the CDC. The IDC is looking to provide 3 facilities, basically the senior debt facility and the VAT facility for them. Some of the key lessons that we've learned with regards to, particularly when we've looked at these special economic zones, is there's significant project delays. There's also issues around the regulatory and policy uncertainties. I think one of the issues that was quite lengthy with regards to the Kuka was how, if they can procure under the, they need to get clearance from National Treasury. So those are some of the issues that we have to deal with. And of course, limited technical capacity is, they are not principally an energy services company, and they're transitioning to do this for themselves. So you need to understand how then will they manage. If you look at the previous slide that I gave you, we're expecting an SPV that probably will have operations and maintenance capabilities. They will probably contract an EPC to do the work, but the asset management would expect that to be inherently sitting within their competences. And you see that most of these SPVs, they don't have those capabilities within. With that, that's a presentation. I'm happy to get some questions. I know you needed to see some numbers. I'm afraid should I? Okay.
Can you tell us a little bit more about the BEE requirements for investing in an opportunity?
So if you look at that structure that I showed you, if I can get to it, there's no pointer. So if there's an SPV that's structured, often they would ask them to provide some equity contribution. So the IDC will cover a portion of that, and usually it's gearing in the 70-30. So they'll still have to have skin in the game. So even the BE partner must have their own contribution, and the IDC would contribute the balance of it. I don't know if that answers the question. So they have to have skin in the game as well. Yep.
Okay.
Yes.
Okay, thank you, Chair. I just want to check, in that case of Kuha financing, SEZ.
Sorry, come again, I didn't hear.
When you are financing Kuha, what model have you used? Were you financing directly the tenants or the entity itself? And what model were you using?
So the Kuka Development Corporation, they own the Special Economic Zone. They are the owners, and they have created a special purpose vehicle that will then install those solar PV on the rooftops of their infrastructure. So they own the infrastructure, and then they'll sell the energy generated to the tenants that sit within the entities. Yes, sir.
I know it's a normal question.
All right, go ahead.
When you are financing, to ask up to a certain limit, what limit are you, or maybe the maximum, the minimum?
Okay.
Maybe you said it.
How much do we finance up to?
Yes.
Okay. I would say we have up to, I would say 1.5 billion rand. Yes, 1.5 billion rand. That's Well, the minimum from the energy unit, remember, I'm talking about the energy unit financing energy projects. The minimum we'll probably look at is 250 million. Yes, ma'am.
Thank you, sir. Do you only fund projects that, well, of course, you fund projects that are done by South Africans, but do you only fund projects that are done within the borders of South Africa, or like the Development Bank, you also look at projects beyond, maybe within the SADC region?
We do look at projects beyond the South African borders. Obviously, understanding the unique country risk profile. If you have a country outside of South Africa in mind, obviously the priority is within the borders of South Africa, because some of our, like I said earlier, some of our mandate speaks to creating jobs, unlocking opportunities in regions within South Africa that we haven't unlocked yet. So some rural communities and empowering the black industrialists in terms of our transformation metrics.
If there's no one, then tell me what's the percentage of your interest?
Okay.
On a loan, because equity, of course.
So those will be probably specific. So depending on the project that you bring to the table, we'll look at the financials for that project, and then we'll advise, anywhere where it's sitting, whether it's prime plus, or depending on the type of project, there are various funding measures. So maybe it could be JIBA plus something, or
yes.
Yeah.
Okay. And my final question is, then when you say the institution that comes to apply for funding might have to have their own contribution, and say it's my brilliant somebody in this room, but they do not have their own contribution, but they can get, I don't know, they can get someone to give them that part of the portion. Are you strict on that, to say you would want it to come from their pockets, or you don't mind that they can be project financing kind of scenario?
No, it doesn't really matter who your partners are. If I get your question correctly, so you could find an investor in your venture, that pretty much bankrolls you.
Okay. No, thank you.
Are there any other questions?
The contact details are there. If anybody does come up with further questions.
Thank you.
Yeah, thank you. Thank you so much.
Thank you. Okay, everybody. We've reached the end of day one of the conference. Thank you to those who stayed till the end. We know it's been a long day. We know that energy levels are low, and you've got a long way to go home, some of you longer than others. So just a quick wrap up before we head out. Tomorrow's sessions, we will start at 8:45, judging by how long it takes people to get here, etc. We did want to start today at 8:30 because we had a very full program, and we had quite a lot of senior speakers at the beginning of the day. But tomorrow we'll kick off at 8:45. We have another slant on tomorrow's program, a lot of new and innovative things that you didn't hear today. So we have a presentation which covers the industrial parks projects that the NCPC and UNIDO are running together. So if you were wondering what any of these projects are about, how maybe you could get involved or how it impacts you, Lehendo will address that. And he's also going to attempt to address some of the questions and issues that arose today. Then our colleague from Vienna, UNIDO in the head office, will address the international standards for industrial parks that are on the way to becoming eco-industrial parks. So the eco-industrial parks international standards. And we will have a session dedicated to various models and tools that parks can use to enhance the eco-industrial parks capabilities within their infrastructure and their management, etc. And then finally, we're going to hear from four or five industrial areas that are going to share their stories. So it's always good to hear from the people on the ground, and that's how we're going to close these 2 days. So please come tomorrow if you are online. Thank you for joining us. And if for some reason you can't make one of the sessions, or today you wished you were 2 people and you could go to both, every single session has been recorded. Thank you to our friendly cameraman at the back there. And they've been streaming this to our LinkedIn profile platform, the NCPC's LinkedIn page, and we have been recording it. And every presentation, with the permission of the speakers, and every session's recordings will get uploaded onto the conference website where you registered to attend. So you're not going to miss out on anything, and we encourage we really do encourage you to share it with colleagues, so that not just those of you who we could bring here today, but the entire community that you work within can actually benefit from these presentations. Drive safely. Thank you for coming, and rest well so that we can have a lovely engagement tomorrow. Thanks, everyone. Bye-bye.